Guys, good morning everyone. Welcome to this session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep. Right guys, very good morning everyone. Yes, and we are finally live after a small wait for all of you, but yes, we are live to bring up the digital electronics Maha Marathon class. Yes, because it's the end game. Yes, it's the last month for the GATE examination and you need to be really serious, preparing very hard for this particular examination, that is the GATE 23, and to help you assist in your journey, to help you excel in the GATE 2023 examination, we have brought you this Maha Marathon, as we came up live last night to give you the all details of what are the activities going to happen this month. Okay, including the Maha Marathons and the other sessions that will be coming after Maha Marathon. Very good morning. So guys, make it big, share it across. Start by liking the session and share the session to all the ones preparing for GATE 23, your college mates, your colleagues, your juniors, your seniors, anybody in your touch preparing for GATE 23, because it's now or never. Because if you don't revise now, it's the last stage, then you lose out of quite significant time. Very good morning everyone, and quickly confirm me. Yes, we are going to rock. Very good morning. So quickly confirm me whether the audio and video is clear. Whether audio video both is clear for you guys. Quickly confirm about the audio and video, guys. Quickly confirm about the audio and video. All right, chalo, let's get started, guys. Let us get started. All ready? Shall we start, guys? Come on, quickly. All clear? All ready? Show your enthusiasm. All soldiers, show your enthusiasm. Let's start. Yes, Hindu, we are going to cover all GATE concepts. Don't worry regarding to it, and that is why we have kept it in two different parts, and that is why we both are putting the efforts together, me and Sanjay sir, so that nothing is missed. You cover up each and everything. Okay, I am live right now. After some time, Sanjay sir will also be joining in this session. Right? Yes, guys, come on, make it big, share it all across, and let's get started with the session. All right, so let's move ahead. Let us move ahead. And before we start up, this is a brief intro about me. This is your mentor and educator Rakesh, and I have secured All India rank 9th in the GATE examination, completed my masters from Indian Institute of Science, Bangalore. And yes, these are my major area of expertise: control systems, math, signal and system, digital electronics, electromagnetic theory, and general aptitude, which I have been dealing for more than 12 years now. Right, before we start up, just a quick reminder that this is the Maha Marathon entire series to boost your GATE 23 preparation. Okay, it's not only digital, it's all the subjects of EE, EC, IN and computer science to be covered systematically, and that is why the entire team is ready for you. The entire team is ready for you. One by one subjects will keep going. Today there will be digital electronics part number 1. Okay, and tomorrow part number 2, but today there will be second subject also. I'll give you the update of that also. Today there will be network in the evening. I'll update you with time and everything, but there will be network in the evening as well, right? Also guys, okay, if you are a GATE 24 aspirant, or maybe your juniors are GATE 24 aspirants, yes, the BYJU'S exam prep on the app comes up with a free mega workshop to deliver 7 success mantra, and it's by your favorite Abhinav Negi sir, who is MTech from IIT Delhi and more than 11 plus years of experience, and he's going to talk about what are the 7 mantras, success mantras from a beginner to a topper. Convert yourself from a beginner to a topper. And also guys, this coming Sunday, that is 8th January at 12 p.m, we have the scholarship test, which can help you get up to 90% scholarship. Yes, right. Yes, Manoj. Okay, chalo. So let's get started, guys. So guys, first of all, let us get started with quick revision of Boolean theorems and the good questions, including, guys, this session will also include the MSQs question as well. Let me tell you, there will be few MSQs also in this particular session. Okay, so guys, we are finally starting. Share it all across and make it big. Make it big, and it's more than 100 watching, so at least there should be a century of likes as well. It's more than 100 watching, so there should be century of likes as well. Let us start with the positive intent. Okay, with the positive intent, let us start by liking the session. Let's have a quick revision of Boolean theorem. So quick review and quick questions. We are going to cover both actually. Okay, so do not worry about that, whether it's going to be questions or only theory. No, it's going to be a combination of both for you. We are going to cover theory, we are going to cover questions. Questions will be of the MCQ form, will be of the NAT form, will be of the MSQ form also. All questions will be there with you, right? Okay, so it's going to be a quick complete revision for all of you. So starting with the Boolean theorem, single variant theorems are very simple. So let's have a quick review of this, that x plus 0 is always equal to x in Boolean and x into 1, no derivation. But yeah, theory covering means quick theory covering, final conclusions like your short notes, and then moving ahead to the question, because question is the need of the hour right now. But yeah, before questions, you need little bit background, you need little bit revision, and that's what I will ensure here. Okay, x plus 1 is always 1. 1 plus x is 1. Similarly, x into 0 will be 0. Now, always remember that whether it is a single variable theorem or multivariable theorem, there is always a duality in the Boolean theorems. There is always the principle of duality in the Boolean theorems. What is the meaning of this duality? This duality says that in any Boolean theorem, you can replace the 0 by plus. You can replace the 0 by 1 and you can replace the plus by dot. The Boolean theorem remains to be same. I repeat again, you can replace the 0 by 1 or 1 by 0, what vice versa. You can exchange 0 and 1, you can exchange plus and dot, the Boolean theorem remains same. You can have a look into the second theorem as well. Right? I can replace the plus by dot and I replace the 1 by 0. Oh, that stands out to be a typo error. X into 0 is 0. Right, x into 0 is 0. I think nobody noted that. Okay, so plus by dot 1 by 0. This one also replaced by 0. Boolean theorem remains to be same. So that is the duality in Boolean theorems. That will be true in any Boolean theorem. X plus x, it's not mathematics, it's not mathematical algebra where it is 2x. It is x plus x equal to x. 0 plus 0 is also 0. 1 plus 1 is equal to 1. Similarly, x into x is equal to x square. Complement and complement will cancel each other. X plus x complement is 1 because one of them will be 1. If x is 1, x bar will be 0. If x is 0, x bar will be 1. So you are guaranteed that minimum 1 will be there and the answer will be anyways 1. And similarly, one of them is 1, the another one is 0. So when you multiply x into x bar, that is going to be what? That is going to be the 0, sir. That is going to be the 0, sir. Okay. If I talk about the multivariable theorem, and before I go to the next, I want you to comment. Let's see your revision status also. Very important theorem in here in the Boolean theorem is the consensus theorem, from where you can get the direct question. Do you all remember consensus theorem? If you remember, type it in the comment box. You can type that, it's easy. Because that's a very important theorem. Directly questions can be expected from it. Do you remember the consensus? If you remember the consensus theorem, do mention in the comment box. By that time, let me also check your revision status. So, dekho. Commutative, x plus y is y plus x. You can swap the operator plus as well as dot. X into y is y into x. X plus y plus z will be x plus y plus z. That is associativity is there. Right. You can add any of the two variables first. Similarly with the dot operator also. X into y plus x into z. Now this is slightly more important. Jahan se zyada questions banta hai. Right. Now of course, this is also a very commonly used data in the question. But this is very pretty obvious. So you are going to use it very repeatedly. Okay, even including this one. These are the ones which are more repeated in the question. Okay, similarly, distributive is the one more repeated in the question. X into y plus x into z will be taking x common, y plus z. Take x common, y plus z. Okay, or you can distribute x over y and z. Similarly, it's dual version. Which is only true in the Boolean world, not in the normal mathematical algebra. X plus y into x plus z will be x. Now I can say x is the common operator, right? X plus y, x plus z. Taking x common, it is whole plus yz. X plus y, x plus z is x plus yz. Very important theorem to be noted. X plus xy, very simple. X is common, so 1 plus y is 1. X into x plus y will also be equal to x. Again, apply the duality here as well. And De Morgan's again is important. X plus y whole bar is x bar, y bar. right? The complement of addition is equal to the product of individual complement. I repeat, the complement of addition, x plus y, is equal to the product of individual complement, x complement into the y complement, right? So similarly, complement of product is equal to the addition of individual complement. X into y whole bar is the x bar plus y bar is the x y. Okay. Some of you have already commented about consensus. Yes, do not forget to check your answers here. Acha. Now, x plus y into x plus z is x plus yz. इस पे थोड़ा सा detailed discussion करना पड़ेगा. This is important. As I told you, x plus y is multiplied by the x plus z. That is equal to x plus yz. That is equal to x plus yz. Acha. Now, what about this? X plus x bar y. What about this? Okay. Yeah, I'll give you the link of Telegram also. X plus x bar y. So guys, what this should be equal to? This should be x plus x bar is multiplied by x plus y if I apply the reverse of the distributive theorem, right? And x plus x bar y is x plus y, a variable and then its complement multiplied by y. Variable plus its complement multiplied by y. The complement is always omitted. Okay, and you are going to feel this is used in multiple places. Okay, this is going to be useful at multiple places. So this is also important for you. X plus x bar y is equal to the x plus y. X plus x bar y is equal to the x plus y. Is that okay, everybody? बहुत बढ़िया. Okay, so that is also a very important thing to be noted also, right? Then if I talk about De Morgan's, okay, this was only two variable. Okay, if I talk about the in general n variable De Morgan theorem, okay, or it is a similar version. Okay, it is complement of addition is equal to product of individual complement. But if I give you a random function, then it's better to always solve. Consensus पे बात पे आते हैं. It is always better to solve through the duality. It is always better to solve through the dual method. What is the meaning of dual? Now let me take you a simple question here. Let me take you to a simple question here. Suppose I give you f is equal to a bar b plus bc bar, and I ask you, dear, and I ask you what is the f complement equal to? Okay, yes, you can apply the De Morgan's. Nobody stops you. You can apply the De Morgan's, but what is the simplest thing you can do? What is the simplest thing you can do? You can first calculate the dual of this function, dear. You can calculate the dual. Now, what is the meaning of dual of a function? Dual of a function is obtained if you replace the dot by plus and the plus by dot. Okay, if you replace the dot by plus, so a bar into b, so I will write a bar plus b. Then I have b into c bar, so I will write b plus c bar. And then this was plus, I will apply the dot in between. That is known as the dual of the function. Okay, now what is the meaning of the f complement? What should be the meaning of the f complement? F complement means that, okay, take the complement of each variable now. Okay, so what is the a complement? Complement a. Then it will be plus b bar dot b bar plus c. Complement each variable individually. Complement each variable individually, right? So complement of any logic expression can be obtained by first taking its dual and then inverting each variable individually. Very simple law to be taken. Very simple law to be taken. Now this doesn't have to be solved in two steps. This does not have to be solved in two steps. Suppose I give you a three variable function a b bar c plus b c bar, something like this. Something like this. Tell me what is going to be the f complement. Sir, it is very, very simple. What you can do? Very, very simple. What you can do? Just write down a ki jagah a bar, right? B bar will be replaced by b and c will be replaced by c bar. They were multiplied. Now they will be added. Dot operator becomes the plus operator. Then I have a plus, so it becomes a dot. B into c bar will become the b bar plus c. Will become the b bar plus c. You can write it in one single line. Okay, so that is how you take the dual. Yes, now let's come back to the consensus. As I told you, this one is the important theorem. So what is that consensus theorem? Already some of you have given the correct answer in the comment box. We start with what? Let us start with, suppose AB. Then A complement multiplied by C. A complement multiplied by C. Okay, I have a product AB and A's complement, first variable complement multiplied by C plus the product of these two terms. The product of these two terms, which is the BC, and the product of the term BC is said to be redundant. We can prove it using the K-map also later on, and then this becomes the AB plus the A bar C. This becomes the AB plus the A bar C. That's it. This becomes the AB plus the A bar C. Acha ji. Right. So remember this, you can expect the direct question from the consensus as well. Some of you already mentioned it correctly. Few minutes back I asked you. Okay, it is the AB plus A bar C, correct? AB plus the A bar C. The term BC is said to be redundant. All right, so let's move ahead to the question now. Okay, some basic questions. Now this is a fact that you must know. It's like a formula again. Let us cover that. So what does this formula say? The number of Boolean functions that can be generated by n variables is equal to how much? Let me see how many of you are able to get this right, because this is a formula that you must have studied. If not, let's revise it right now. The number of Boolean functions generated by n variable. How many Boolean functions can be there for n variable? Yes, guys. So looks good, yeah. Your preparation looks good. Come on, all others looks good. The preparation looks good. Yes, it is the C. 2 power n. Now, this is in terms of n variable. What they can say, they can ask you in terms of, the number of Boolean functions generated by 4 variables or generated by 3 variables, etc. Okay, so you must know that it is 2 power n. Going ahead to the next question, simplify the Boolean expression. So let's play with the simple Boolean questions and then move ahead towards the logic gate questions as well. Okay, logic gates, delay based question. Okay, the good delay based question of logic gates, NAND and NOR based questions, XOR good logical questions. All this will be first covered, and then we'll move on towards the next topic. X plus y bar plus xy bar plus x bar ka whole bar. That's simple. Tell me the answer. Here I can apply the distributive law. Okay, x plus y bar is x plus y bar. So this is x. Y bar is 0. So ye to finish ho gaya. Right. Now what should be the answer for this? Xy bar plus x bar ka whole bar. I can write this as x bar plus xy bar. Pehle isko reverse kiya. X bar plus xy bar and then whole bar. What is this further equal to? Now see, x bar. Oh. Guys, I think there is a power cut. This should not have happened. We usually don't expect this, but it should be back. Immediately it will be back. Don't worry, hai? Just do not panic. It should be back automatically. So x bar plus xy bar ka whole bar. That will be equal to how much? That will be the x bar plus y bar. Because the variable and its complement, x is the complement of x bar, so that will be omitted. Right? So I omitted x, so I have x bar plus y bar and then whole bar. So that is simply xy. So your answer now should be equal to how much? Your answer now should be equal to x plus xy. Yeah, it's perfect. The power is back. No issues, right? Okay. Now this is x plus xy, which is equal to x. Very simple. Answer should be the A. Answer should be equal to A. Yes, many of you have given that already. Isn't it, guys? Right, correct. Perfect. Next question, sir. What is the next question on board? Okay, it's again a Boolean based question, and then we will take some MSQs also here. We'll take MSQs also. Just be ready for MSQs also. Yes, guys. Right, and we haven't still hit the century of likes, guys. Come on. Okay, we are so lazy in this morning. It's a cool morning, I know. Okay. Bilkul, Raghu. Okay, so A into A plus B bar C bar plus C. Let me write down this expression separately first of all so that we can simplify. We have A plus B bar C bar plus C plus the B bar multiplied by C plus the A bar plus the BC whole multiplied by the A plus B bar C plus AC bar. This should be equal to the 1. Right. This should be equal to the 1. This session total will be there till 2 p.m. Paul, till 2 p.m. it will be there. But in between, Sanjay Rathi sir will also join. So we'll keep switching. Don't worry. Sometimes me, sometimes Sanjay Rathi sir. So now, what is this equal to, everybody? Okay, now, what is this actually? From wherever you can extract some information, let us do that. Okay. What is this condition given? If C is equal to A bar. Achha, let us replace that C is equal to A bar. I will put C is equal to A bar, and there are multiple places where C bar is there. So C bar will be equal to the A. C bar will be equal to A. So A plus B bar, C bar will be A plus C, which is equal to A bar, plus the B bar, again C, which is A bar, then again a bar, then BC, C is again equal to the a bar, correct, multiplied by a plus b bar c, c is a bar, plus a c bar is equal to a, this is net equal to the 1. Right guys, anybody got the answer? Please do comment here as well. Okay, now a plus a bar, भाई देखो ये हो गया कितना, a plus a bar is 1, right, and 1 plus anything is 1, so I have got a into 1, plus आगे देखते हैं a bar plus a bar plus a bar b, देखो ये हो गया b bar, I take a bar common, it is 1 plus something will be 1, so it's only a bar left here. Okay, but there is a term multiplied also, and from this term a plus a is a. Okay, this is equal to how much, dear? This is a plus a, which is equal to a, and then you have a plus a bar b bar. The variable or the complement will be omitted. You are left with a plus b bar only. You are left with a plus b bar, right? How much is this further equal to? First term is equal to the 1 plus, देखो, now a bar into a, this is just 1. A bar into a will be 0. B bar into b will be b bar. So I am left with a bar b bar only, right? And a plus a bar b bar, again the variable is omitted and it is a plus b bar. The answer is a plus b bar, the variable will be omitted. Now a plus b bar should be equal to right hand side 1. Answer is a plus b bar equal to 1, right? This is a complement which is not very clearly visible here, but I will make it visible now. Okay, a plus b bar is equal to the 1 is the correct answer, option number C, right? Option number C, right? Some of you, actually many of you have come up with the option number C. Great going, that means we are all great going. That looks like a great session going ahead. All okay. So let me test your knowledge with the next question here. Okay guys, please have a note that I have now given you a MSQ question. Which, if w, x, y, z are Boolean variables, which of the following is correct? Which of the following is correct? Come on, do answer me this question. Come on guys, do answer me this question. Right, w, x, y, z are Boolean variables. Which of the following is equal to the correct answer? Is correct. So we'll step by step simplify this. Everybody, MSQ question, be ready for MSQs in the GATE 2023 examination, right? And don't worry, we are going to bring you the separate MSQ series as well. Okay, so wx plus y plus x into x plus y is x plus wy. Okay, whether it is correct or not, you have to just check that. So step by step check karte hain. We'll just take up A here. Okay, in the option number A, wx, right? W को अगर मैंने कॉमन ही ले लिया from the first one, I have wx plus y, then I have x into x multiplied, that is x, then further plus xy. This is equal to w, x plus x is x, so x plus y plus x, 1 plus y is common. Now this is further equal to, from this I can take x common, then I will be left with w plus 1 plus wy, w plus 1 is 1, so answer is x plus wy. Or sir, answer is x plus wy. A is correct, but it is a MSQ question. You can't stop here. It is a MSQ question. You can't stop here. A to correct hai, but you have to check the other options also, since it is a MSQ question. Option number B. Let us take the option number B also very patiently here. wx bar plus y plus z bar ka whole bar. So De Morgan's or duality method will be applied, plus w bar x, whether this is equal to right hand side or not. So let's check that guys. Okay, now apply the De Morgan's step by step. Okay, wx bar plus y plus z bar. Okay, so it is going to be w bar plus x, plus becomes dot, y becomes y bar, again plus becomes dot, z bar becomes z, plus w bar x, right? Even if you open up the terms, it is going to be first term w bar y bar z plus x y bar z, w bar y bar z plus x y bar z plus w bar x. W bar ko common मिल लिया तो x plus y bar z, no, nothing can be taken common. From here if you take x common, w bar plus y bar z, no, nothing is common, so this doesn't match. Anyways, at any cost, B doesn't match. Okay, the B doesn't match. Let's go for the next one then. Let's try to take the C option. Take the C option. Okay, wx bar, let me write down this first of all. Wx bar into y plus कितना है? Y plus xz bar, y plus xz bar plus w bar x bar plus w bar x bar whole, total whole multiplied by the y. Total whole multiplied by y. Now let us simplify this. Okay, so this is equal to w x bar y plus, the second part will be 0. X bar into x will come, that is equal to 0, plus w bar x bar multiplied by the y. So w x bar y into y is 1 plus w bar x bar y. W bar x bar y. From here you can take the x bar y common. Am I correct? You can take the y into y 1 ho gaya. I can take the x bar y common and w plus w bar will be 1. So answer should be the x bar y. Is that what is given? X bar y. No, they have given x y bar. They have given x y bar. They have given to be x y bar. Right? X y bar. My answer is x bar y. So that is also not correct. That is also not correct. Okay? That is also not correct. Right? What is that one more term you're referring to? ठीक तो है. Voice glitch कहाँ से आ गया? Referring to? ठीक तो है. Voice glitch कहाँ से आ गया? Referring to? ठीक तो है. Voice glitch कहाँ से आ गया? Referring to? ठीक तो है. Just let me check out. Guys, by the time check the D option, let me check out the voice for a moment. Yes. Okay, so D is coming. Let me check the voice once again. Yes. Okay, so D is coming. Let me check the voice once again. Little bit trouble is still there. Okay. Let's see for 1 or 2 more minutes. Otherwise, I'll contact the team then. Okay, so yes, guys, whether D is correct, have a look into this. Have a look into this. Many of you say D also correct. So W plus Y is multiplied by what? It is multiplied by WXY plus WYZ. WXY plus WYZ is multiplied by W plus Y. This is equal to what? This is equal to what? Let's check it out, guys. Okay, so WY is clearly common from here. W plus Y, from the next term WY is common. Then I'm left with X plus Y. Now, you can check this. W, if you multiply inside, W into WY will be WY plus W into Y will again be WY, okay, into X plus Y. WY plus WY is a single WY into X plus Y, right? So it is WYX plus WY, out of which WY is again common, X plus 1 is 1, so answer should be WY. Answer should be the WY. Acha, this also is equal to WY then. Acha, they have stopped it here. They haven't simplified that further. WY common X plus Z. WY common X plus Z. WY oh sorry. Correct. X plus Z ही है. यहीं तक solve होगा. WY common X plus Z. Okay, this is X plus Z. Done है. This is X plus Z. Correct answer. So D is also matching up. D is also matching up, and this is the MSQ question. The correct answer for the MSQ question is the A and D, dear. The correct answer for the MSQ question is A and D. That is the A and the D, right? That is the A as well as the D. All right, done hai? Let's move ahead to the next question then. The correct answer is A and D. Cool. Let's move ahead to the next question then. All ready for the next question. Now, this was the MSQ question based on Boolean. We'll show you a next question here. Have a look into the next question. This is a GATE 22 1 mark MSQ question. Although 1 mark, but MSQ question from the basic Boolean laws. Select the Boolean function equivalent to x plus yz, where x, y, z are Boolean variables, and plus denotes the logical operation. Okay, choose the Select the Boolean function that will be finally equivalent to x plus yz. Come on guys, a gate 22 question for your reference. Have a look into this step by step. X plus z plus xy. From this, x can be taken common. 1 plus y will be 1 plus z. So it is x plus z. This is not x plus yz. No, that is not x plus yz. Right? So it's x plus z. X plus z ही तो लिखा. X plus z only, na? Correct. It is x plus z only. Now, what is this equal to, dear? What is this equal to? X plus y, x plus z. Distributive theorem, guys. This is the direct distributive theorem. Direct theorem. This one is what? This one is the direct theorem. X plus y z. X plus y into x plus z is x plus y z. Correct? Next, x plus xy plus yz. Out of which x is common in the first term, 1 plus y, then plus yz. 1 plus y is 1, so I am left with x plus yz. So B correct, C correct, D भी check करेंगे. In the D, x is common in all the terms. 1 plus z plus y, 1 plus anything is 1, so it is only equal to x. It is only equal to x. So what is the answer for the MSQ question, dear? What should be the answer for this MSQ question? Two options are correct, that is the B and C. Two options are correct and that should be equal to B and C, everybody. Two options are right. That is option B and the option C. All okay with that, and let's move ahead to the next question then. Okay, next question then. If xy is equal to 0, what is x XOR y? Questions based on property of XOR. Okay, questions based on the property of XOR. What is x XOR y? Questions based on property of x. The voice is very clear right now, Chandrasekhar and Latesh Naik. Okay, voice is very clear. The voice is clear right now. Okay. If xy is 0, what should be the x XOR y? What should be the value of x XOR y? If xy is equal to 0. Tell me, dear. Tell me, dear. Tell me, dear. Now, guys, I am not making a chart of the logic gates. Guys, you know what is AND gate, OR gate, NOR gate. We will take up the questions on Boolean theorems. I made you revise. For logic gates and for logic functions, let's take up the question directly. Everybody knows what is AND, OR gate, NAND gate, XOR gate. Okay, the variety of questions you should be able to handle. So I don't think at this point you need what is the AND gate, what is the XOR gate. No, but yeah, you need the variety of questions that can come up from here. In case you have any doubts or anything you need extra, let me know. Okay, so xy is 0, what should be x XOR y with a condition? Normally x XOR y is x bar y plus xy bar, but xy is 0, right? Xy is 0, so this is xy and I want x XOR y. Now 0 0 0 1 1 0 1 1, these are the four combinations of xy normally, but question has given you a condition that if xy is equal to 0, if xy is equal to 0, so in these cases xy is equal to 0. Last case xy is equal to 1, but xy cannot be equal to 1, so you don't have to take this condition. Now what is XOR? XOR will remain to be same. 2 input XOR, it will produce the high output when both the input bits are different. So this is different, this is different. 0 1 and 1 0 are different. But what will you do with the last combination, dear? What will you do with the last combination? 1 and 1, what will you do with that? This is the input which is not going to occur. This is the input which is not going to occur. So you are going to take it as don't care. Output will be treated as don't care because this is the input not going to occur. Now, how do you treat the don't care? It can be either 1, it can be either 0 based on your choice. Okay, you can take it either using the K-map, okay, but 2 variable, no need K-map. K-map also we will solve gradually, right? But if it is 2 variable, we don't need the K-map. Dekho, agar don't care, if you take it to be 0, suppose, then it becomes the proper x XOR y. Then it becomes the proper x XOR y. That is x bar y plus xy bar. But if you take x is equal to 1, don't care means it can be anything. I don't really care about that. If I take x is equal to 1, then it is going to become the OR truth table. Then it becomes the truth table of OR. The output is high whenever even a single input is high. Can I say it becomes an OR gate then? If x is equal to 1, x XOR y will become x plus y. OR gate actually. OR gate. Now which of them is the reduced form? You only decide. Here only one OR gate is required. Here you require an OR gate, you require inverters, you require 2 AND gates. Definitely, x plus y, it is a reduced version. So the simplified form is going to be the x plus y. It behaves as an OR gate. Okay. So because it's a two variable case, I did not go to the K-map. K-map we will deal separately. I have K-map also in this particular slides only. All right, everybody. So answer is x plus y. Answer is x plus y. Done hai? This is how I can treat that. This is how I can treat that. Let's move ahead to the next question. If y is a XOR b XOR ab, y is a XOR b XOR ab. Dun, dun, dun. Yeah, it's fine now. It's fine. It's fine. There was maybe a small buffering. It should be fine now. It should be fine. I refreshed. There was no buffering. I think there was some issue with the studio only, right? It's all okay now. It's all okay. It's all okay. Come back to this. Again, an XOR based question. Y is a XOR b XOR ab. What should be the simplified expression for y? A XOR b XOR ab. What should be the simplified expression for y? Guys, and do not forget to subscribe the channel because there are many more marathons coming for you. Every update, every notification will be there for you. So if you have not subscribed, do not forget to subscribe the channel now. Right? Take it up. A XOR b XOR ab. What is the simplified expression for the y? What is the simplified expression for the y? Okay, it's an XOR of 3 bits. Okay, but 2 are ab and third is the function of ab. Third is the what? Third is the function of AB. तो देख लेते हैं A, B, A XOR B, A and B and A XOR B, and then I will write down Y. Sorry, why I'm writing A XOR B? AB, A, B, AB, and then I want to write down the Y. And then I want to write down the Y. 0, 0, 0, 1, 1, 0, and 1, 1. Normally, these are the 4 output conditions. These are the four combinations of AB. Okay, now what should be AB? AB is the product of A and B, so it is 0, 0, 0, and finally it is 1. Only 1 into 1 will be giving you 1. Now Y, it is equal to the XOR A XOR B XOR AB. A XOR B XOR AB, right? It is the A XOR B XOR the AB. Clear hai? A XOR B XOR the AB. Now tell me, XOR gate will produce high output. 3 input XOR gate will produce high output when there are total odd number of ones. When there are total the odd number of ones. So where are the odd number of ones? Where are the odd number of ones? 1. ये आ गया 100 odd number of ones. 111 odd number of ones. But Y has to be a function of two variables A and B. So if it is a function of two variables A and B, according to the two variable AB, when you look into the truth table of Y, it is again the OR gate. 0, 1, 1, 0, 1, 1, output is high. Matlab, even if the single input is high, the output is high. That is again the XOR gate. So output is A plus B. Output should be the A plus B. Output should be the A plus B, A plus B, A plus B. It is the C, everybody. That is equal to the C. Is that okay? The correct answer is equal to C. The correct answer is equal to the C. The correct answer is equal to the C. Right? Chalo. Next question, guys. Moving ahead. Okay, what is the minimized expression for y equal to A XOR A plus B? A XOR A plus B. Come on, everybody, tell me. A XOR A plus B. What is the minimized expression for A XOR A plus B? Simple hai na? XOR A is distributive, so you can open this A XOR A XOR B, A XOR A XOR B. But what should be A XOR A? It is the same. This is known as the same, right? And same pe XOR will give you the 0 output. So answer is only going to be A XOR B. Is that okay? Answer is only going to be A XOR B. Answer is only going to be A XOR B. Is that okay, everybody? This can be simplified by the property. You can also expand this by the truth table. You can also expand this by the truth table. You can also expand this by the truth table. A, B, A plus B, and then the output. What is the output named? Y. Now 0, 0, 0, 1, like the previous questions. 1, 0, 1, 1. A plus B is 1 here. right? It is 0 here. Now y has to be the XOR of a plus b. Y has to be the XOR of a and a plus b. Look into these two. 0 0 0 0 1 different, 1 1 same, 1 1 same. Take second. 0 0, this is 0 and 1. Okay, this becomes 1 and 1. No, there is some issue. What is the fundamental problem happening here? A, B and A plus B. A, B and A plus B. This is 0 and 1. ये same हो गया. 1 and 1. 1 and 1. Only one case it is different. It is coming to be A bar B. No. Let me just check that out, guys. I'll just update you on this confirmly. Right. A XOR B ही जाएगा. Okay. No, according to the truth table, it is A XOR A plus B. A plus B is 1 here. And then this is 0. Ye different. Only one different combination is actually coming. Only one different combination is actually coming. And truth table is the most trusted form. It has to be A bar B. It has to be A bar B. Then I'll just check up what goes wrong. I'll update you. I'll check it out in the comment box only. It has to be A bar B only. It has to be A bar B, right? It has to be A bar B. Don't worry. It has to be A bar B. Chalo, ठीक है? Maybe something in hurry bari I missed out there. But don't worry, it has to be A bar B only. Because truth table can never speak wrong. Truth table always speaks the truth. That is why we call it as the truth table. It always speaks the truth, and only there is one input combination for which the output is the different. For which the output is different. ये भी हुआ same, ये भी हुआ same, ये भी हुआ same. This is the only case which is different. Everybody okay? Everybody okay? It has to be A bar B. Chalo. Now, as I mentioned, some of the properties of XOR that is going to be used. Okay. हाँ, Sai Charan. Correct. What is the minterm expansion for PQ plus QR bar plus PR bar? What is the, no, they have not asked you to simplify here. That is actually expansion here. Okay. Actually expansion here. Yes, Nishu. Yes. Correct. I just quickly wrote that only. Okay. What is the minterm expansion of this term? PQ plus QR bar plus CR bar. So this is an expansion. This is not the minimization. Right. Hi Aditya, I am all good. How are you? एकदम बढ़िया हूं मैं तो. आप लोग कैसे हैं? Okay, guys, tell me what is the minterm expansion for this? इसको expand करना है. Now in the form of minterm, and because it's a 3-variable term, it's a 3-variable function, the minterm should be a product of 3 terms. It should be a product term containing the 3 different terms, and tell me what should be the answer. तो देखो, how to deal this? P, Q, Q, R bar, P, R bar, right? What is the P, Q? Now, P, Q, R mein R is missing. For minterm, I should have the 3 terms. 3 variables in each term. So P and Q, it is 1 and 1, but R is missing. Right here, Q, R, P is missing, Q is 1, R is 0. When do you write down R bar? When R is 0. Whenever a variable is 0, you write down the complement. Whenever the variable is 1, you write down directly. Similarly, this is P, R bar. P is 1, Q is missing, R bar. R bar matlab R is 0. Now, whatever is the missing variable, that can be 0 or 1. ठीक है, 0 और 1 में से कुछ भी हो सकता है. So this could be 1 1 0 1 1 1, 0 1 0 1 1 0. ये आ जाएगा 1 0 0 1 1 0, 1 0 0 1 1 0. Thank you आदित्य. Okay, now अगर आप minterms की list create करेंगे, this is 6 7. Okay, this is 2 6 and this is 4 6. 6 is repeated. So overall it is 2 4 6 7. What are the minterms? 2 4 6 7. Sir, answer is A. Everybody, the answer is equal to the A. The answer is equal to the A. ठीक है? So this is the minterm expansion. Next question. Given F1 and F2 in the form of minterms, tell me the minterm expansion for F1 bar into F2 bar. F1 bar into the F2 bar. F1 and F2 का minterm expansion given है. Right. F1 bar into the F2 bar, that is the F1 plus F2 whole bar. Yes, Aditya, please only comment once. Okay, don't spam the comment box. Do it. Whatever you reply, I appreciate. Please write it only once. Okay. Okay. F1 into F2 whole bar is F1 plus F2 whole bar. The De Morgan's law can be applied. Now, what is F1 plus F2? Whenever the function is given in the form of minterm list, F1 plus F2 can be obtained as the union of the F1 and F2. Can be obtained as the union of F1 and F2. So that becomes summation of what? Now union 0, 4, 5, 6, 0, 3, 6, 7, 0 common hai. Union includes the terms which are in A or B or both. Ya to A mein ho, ya B mein ho, ya dono se ho. Right. So this is equal to 0, then 3, then 4 is here, 5 is here, 6 is common, write down once, and 7. 0, 3, 4, 5, 6, 7. 0, 3, 4, 5, 6, 7. 0, 3, 4, 5, 6, 7. Bye bye, Aditya. So, here, what is the F1 and F2 whole bar? What is the F1 and F2 whole bar? What is the F1 and F2 whole bar? Right? Whole bar. Now, what will be the minterms coming up here? What will be the minterms coming up here? Okay, the minterms which are missing in the F1 plus F2, that will go into the complement. So, 1, 2, only 1 and 2. Sir, only 1 and 2. Only 1 and 2. The correct answer is B. The correct answer is equal to the B. The correct answer is equal to the B. Right, everybody? The very correct answer is equal to the B. Mohammed Anas, minterm and maxterm. Chalo, suppose if you want to understand minterm and maxterm, suppose I tell you, okay, that you need to design a prime number detector. Dhyan dena. Suppose you need to design a prime number detector. Okay. How will you design a prime number detector? Pay attention. How will you design the prime number detector? Okay. So, prime number detector 3-bit ka in the 3-bit form. Understand in one single go. So, I have ABC and I have the function F. The function F should be high whenever the input is a prime number. Or you can design any such circuit. Okay. So, 0, 0, 0. First, write down all the combinations. First, write down all the combinations of ABC, right? And the output will be high whenever the input is a prime number, okay? Input is a prime number. Jayesh, one question from COA. Okay, maybe 1 or 2 marks that we really can't exactly predict, but yeah, we'll bring you the COA marathon. That is a separate session planned and we'll bring it through a separate faculty, and there will be a detailed marathon for that, Jayesh, okay? Don't worry regarding to it. Okay, chalo, so come up here. Dear, come up here. ABC is 0, 0, 0. What should be the output F? Okay. Now, output is high only when the input is a prime number. So, prime numbers are here. 2, okay, then 3, and then 5, and then 7. These are the prime numbers, na? 2, 3, 5, 7. Out of this, rest are non-prime. Okay, these are consonants. Oh, sorry. Sometimes slip of tongue occurs. Board hang ho gaya. Just a moment, I think the board has hanged. Okay, so these are the 4 cases where the output will be high. These are the 4 cases where the output will be high. Now it's okay. Okay. Yes. Now, how do you write down this output without simplifying? How do you write down this output without simplifying? F is equal to high where 0, 1, 0. I told you 0 means bar, 1 means normal. Again 0 means bar. So A bar, B, C bar. Clear hai? A bar, B, C bar. Plus the next term that you will write is A bar, B, C. Plus the next term that you will write is 1, 0, 1. So A, B bar, C. And the next term that you will write is 1, 1, 1. That is A, B, C. Now if you see, each of them is a product term. Each of them is a product term, and the product term is a product term of 3 variables, and each of this term is a minterm. Each of these terms is a minterm. All of them are the minterms, sir. All of them are known as the minterms. All of them what are known as the minterms. Okay. And this is a form which is known as, now you see, minterms are product terms. Okay. Minterms are product terms. Take a please. Okay. And you are adding up the product terms. You are adding up the product terms. This is known as the SOP form. Canonical SOP form. What is SOP here, dear? What is the SOP? Sum of product. What is the SOP? Sum of product term. What is the SOP, dear? Sum of the product term. Sum of product. Don't worry, guys. Within a few seconds, the power will be back. Don't worry. Okay, so this is known as canonical SOP form. But can you also simplify this? Can you also simplify this? Dekho, if you open the bracket now, what can you do here? From the first two term, A bar B is common. So F is also equal to the A bar B. Then there will be C plus C bar, which is the common. Okay. Or actually, C bar plus C is common, one and the same thing. Plus, guys, from the last two term, right? From the last two term, AC is common. From the last two term, dekho, AC is common, and then B bar will plus B will be equal to 1. So what is the function actually equal to? A bar B plus AC. A bar B plus AC. Now please tell me, okay, we have a term A bar B. Okay, is it equal to a min term? Please everybody comment. I have a term here A bar B, or I have a term here AC also. Is this a min term? Tell me first yes or no quickly. Yeah, I'll share my Telegram group as well. Don't worry. Is this a min term, everybody? I just need to check whether that is okay for you or not. Come on, quickly, everybody, quickly. And guys, I have shared you my Telegram link, the PDF of today's session, the complete PDF, whatever I teach, Sanjay sir teach. Okay. Ankita for product F1, F2. है ना? ठीक है. Satyam Mishra, whoever sent you, go back to that particular person. ठीक है. So A bar B and AC. A bar B and AC. They are not min terms. They are not min terms because they don't contain the three terms. I am talking about a three variable function and it's a product of only two terms. They are not min terms. These are not min terms now. These are not min terms now, right? Okay, but they are simply known as some product terms, right? Also known as implicants, right? They are known as product terms. They are also known as implicants, dear. They are also known as the implicants. Okay. What is this form of the function known as? This form of the function, that is also SOP. Sum of products. They are product terms and then you add them. That is also SOP. But what type of SOP? This is known as the standard SOP, or simply known as the minimized SOP. Reduced SOP form. Clear? This is also SOP, but that is the standard or minimized SOP. The previous one was the canonical SOP. Okay, the form that you directly obtain from the truth table. Okay, that is the canonical. Okay, that is the canonical. Chalo, done. Okay, so this is what all about min terms that you should know. This is all about the min terms you should know. Okay. Next, let's move ahead to the next case. Acha, min term and max term ka relation. Let me cover that also quickly. So what is going to be the F bar now? From here, if I include the F bar column, ye bhi kar lete hain very quickly. Very quickly, if I write down the F bar also, dear. Very, very quickly, F bar. So F bar is high. F bar is high when the F is 0. When the F is 0. So let us write down the F bar very, very quickly. Then let's move ahead to the next case. Let me write down the F bar very, very quickly. Kya ho jayega? F bar 0, 0, 0, 0, 0, 1. How do you write down 0, 0, 0? A bar, B bar, C. Then 0, 0, 1. A bar, B bar, C. Then you have next at 1, 0, 0 and then 1, 1, 0. 1, 0, 0. And then 1, 1, 0. But this is equal to F bar. So what is going to be the F, dear? What is going to be the F? So again, if you apply the De Morgan's or the duality method, the F is going to be A plus B plus C. Dot. A plus B plus C bar. Dot. A bar plus B plus C. Dot. A bar plus B bar plus C. Okay. Now, each of these four terms is a addition term. It is a sum term. But it is the sum of what? It is the sum of products. This product term, this sum term, it is the sum of three variable, and sum of three variable term will be called as the max term. So a term in which you have sum of all three variables, because it is a three variable function, it is a max term. And what is this form known as? Now you have some terms and you take the product of it. So that is the canonical POS form, dear. This is not SOP, this is the POS form, product of some form. This is the POS, product of some form. Okay. And all these four terms are known as the max terms, right? Every max term, let's say MI, will be the complement of the min term. We represent min terms by small m, max terms by capital M. Every max term and min term, they are complement of each other. Okay, so I think this much revision is sufficient for max term and min term. Time to move ahead to the further questions also. Moving ahead from max terms and min terms. Okay, yeah, come on. Again, a simple logical XOR based question. Logical XOR based question. What is going to be the value of y here? What should be the value of y here, everybody? What should be the value of y here? Come on, everybody, quickly tell me what should be the value of y here. So see, there is the XOR gate with the input A and B bar and with the input A and B. With the input A and B. Some basic properties of XOR to be revised here. Some basic property for the XOR to be revised here. Okay, what are the different properties of XOR that you can use here? Guys, what is A XOR A? It will be always 0. Already we have used this. A XOR A bar. A and A bar are different. The output will be 1. Okay. Now A XOR B. Okay. A XOR B complement is known as the XNOR. Okay. Some more properties. In the A XOR B, whenever you complement a single variable, A bar XOR B, that will also be A XOR B ka whole complement. That is the XNOR. That will become the XNOR. Right. A XOR B bar is XNOR. But if you complement both the variables, A bar XOR B bar will be same as A XOR B. Dhyan rakhna. So in the XOR, if you complement a single variable, the answer becomes the XNOR. Right? Similarly, if I talk about the XNOR, A XNOR A and A is same, the XNOR will give the high output. A XNOR A bar, A and A bar different, so XNOR will give the 0 output, right? Similarly, A XNOR B whole complement, XNOR complement is the XOR, right? Same properties in the XNOR also, if you complement one of the variable, that converts to the XOR, right? A bar XNOR B or A XNOR B bar is equal to the A XOR B. If you complement both of them, A bar XNOR B bar, that will be A XNOR B. No change there. Clear? Okay. By using these set, not only all of them, some of them will be used here. Now let us see, guys. What is this? Everybody, let us try to answer this question quickly. This is A XOR B bar. Sir, what should be A XOR B bar? Quickly. What should be the A XOR B bar? That is A XOR B. But this one is A XOR B. Okay. Now, next is C bar XOR D bar. That should be C XOR D. There isn't any issue here. Okay. Both complemented, the answer will be XOR only. And what is this? C bar XOR D. What is C bar XOR D? Will be C XOR D. Now, what I can tell you here that, suppose guys, A XOR B is equal to X. So, XNOR will be X bar. Chalo, X nahi, A or B ke terms mein le lete hain. Okay. Suppose A XOR B is equal to A. Is equal to P. So, XNOR will be the P bar. Now, if C XOR D is equal to Q, so C XNOR D will be the Q bar. Now, what is the situation that is building here? Right. What is the situation that is building here? You have a 4-input XOR gate. In which two of the inputs are P and P bar. Right. Two of the inputs are Q and Q bar. What should be the output now? Right. Okay, Kavya, welcome to the session, and do subscribe if you want to prepare for GATE. Tell me. What should be the output? Now, very simple that from the P and P bar, there will be a single one. One of them will be 1, another one will be 0. And from Q and Q bar, also you will have a single one. You will have a single one. So total, how many ones are there? On the 4 input lines, there are total 2 ones. Right? And there are even number of ones. Whenever the input contain even number of ones, XOR output will be 0. XOR output will be 0. Clear? Good logical question. Property based, good question I will call it. Okay? It's a good property based question. Okay, I hope it is clear to all. If there is any confusion, please let me know. If there is any confusion, please let me know. Let's move ahead to the next question then. Okay. Yeah, let's take this next question from the basic logic gates. Basic logic gates. What is the output in this following circuit diagram? What is the output of the following circuit diagram? Okay, so what are the inputs to the different gates? They go first directly M, N, Q. So this is M, N, Q whole bar. Okay, next N, this is M, this is N bar actually, and this is Q only. So this is M, N bar, Q whole bar, right? This one. And last May, this is M bar, this is coming from N, and this is Q. So this is M bar, NQ. M bar, NQ. Right. Right. Okay. So what should be the output Y now? What should be the output Y now? It is again the NAND. M, N bar, M, N, Q. M N Q whole bar multiplied by M N bar Q whole bar multiplied by M bar N Q whole bar, and then product ka whole bar, NAND gate ABC whole bar, right? ABC whole bar. So what is that equal to? That is equal to MNQ plus MN bar Q, right? X bar, Y bar, Z bar ka whole bar will be X plus Y plus Z, De Morgan's you can apply, plus M bar NQ. Now further from the first two terms you have MQ common, N plus N bar will be 1 plus M bar NQ. Okay, further you can take the Q common and then you have M plus M bar N. Dear, M plus M bar N, so M bar will be omitted, so answer is Q into M plus N. Answer is Q into M plus N. Q into M plus N. Q into M plus N, answer is D. That is known as the Q into M plus N. Okay, everybody? The correct answer is equal to the Q into M plus N. The correct answer is equal to Q into M plus N. Q into M plus N. Right? Next question. Now, let's quickly talk about the NAND and NOR. How many NAND gates and NOR gates are required to implement a circuit? Because that is the next important gate. Minimum number of NAND NOR gates required to build up a circuit, required to complete a circuit. So, NAND gate as universal gate. NAND gate as the universal gate. So, if you short both the inputs, let's have a quick review. If you short both the inputs, the output becomes A into A ka whole bar, that is A bar. So, that is the NOT gate. Right. Then, this is first the NAND gate which takes the AB whole bar, and then both inputs shorted, it is the inverter. It is the inverter AB whole bar will be AB. So the second diagram is the AND gate. It is the AND gate, okay, which requires two NAND gates. And similarly, here I feed A, here I feed B. So this is the inverter which gives A bar, this will give B bar. And now what will you get here is A bar into B bar ka whole bar, which will be further A plus B, and hence this is the OR gate. And NAND gate is able to implement all the basic gates AND, OR and NOT, and hence it is a universal gate. Okay, similarly, now because it is a universal gate, you can build any Boolean function, you can build any special gates like XOR and XNOR also. XOR where we need the 4 NAND gates, you can verify how it is XOR. Of course, this is A and B. Okay, let's not waste the time there because this is what you must be already knowing. Similarly, XNOR gate ke liye there will be one more inverter at the end that I will apply. Okay, similarly, the same results for the NOR gate. This is A, right, and this is going to behave as OR gate. This is A, sorry. This is the NOT gate, first of all, inverter. Then this one is the OR gate, and this is going to be the and implementation using the NOR. This is the basic theory that I'm giving you as slides. You can refer to it. I have explained you once. This is the implementation of XOR gate, which will use the 5 NOR gates, and the XNOR gate, which will use the 4 NOR gates. Okay, and this is the count. Okay, a very basic count about the important gates that you must remember. For NOT gate, how many NAND and NOR gates are required? For AND, for OR, for XOR, and for XNOR. This is the tabular conclusion of the number of NAND and NOR gates for the important gates, the basic gates, and NOR, and OR and NOT, and as well as the XOR and the XNOR gates. Okay, now what the type of question, that is a basic theory, but what the type of questions that can be expected from here? Okay, first let me take a simple question, direct simple question in the form of MSQ. Everybody take up this MSQ question. As I told you, this session will also keep bringing you the MSQ questions as well. Take up this question and answer me. Everybody, MSQ. MSQ. Everybody dear, MSQ. Tell me the answer. If y is a function of ABCD, which is summation 1, 2, 4, 7, 8, 11, 13, 14, then y is A XOR B XOR C XOR D. Right? X plus y plus z is x plus y plus z. This represents commutative law. This is wrong. This is not commutative. No? This is associative. Okay. Commutative is swapping of the variables in the operator. X plus y is y plus x. This is associative law. This is not commutative. This circuit is a 4-bit gray to binary code converter. Tell me whether right or wrong. Okay, the combinational circuits will be covered up later. But yeah, this is actually what? This is actually circuit ko maine yahan copy nahi kiya, but yes, this is MSB to MSB copy. Okay, then whether it is gray to binary or binary to gray, that you have to check. Whether it is gray to binary or binary to gray, that you have to check and tell me. Right? Yes. And then the minimum number of 2 input NAND gates needed to perform the function of 2 input OR gate will be equal to 3. This is correct. ये तो अभी मैंने आपको discuss किया ना. Okay, the number of NAND gates for a OR gate will be 3. ये correct है. D is at least correct. A and C you have to tell me. Right? Guys, it is MSB to MSB copy. Okay, this is B3, this will be G3, and if I call this is B2, so this is going to be G2, B3 XOR B2. Then this is going to be G1, B2 XOR B1, and B1 XOR B0 will be the G0. It is binary to gray actually. It is binary to gray. For gray to binary, the previous XOR result is further XORs. Try to recall. But combinational circuit आगे आ जाएगा. Sanjay sir will cover that. But this is not gray to binary. It is binary to gray actually. Right? It is actually binary to gray code converter. But this is confusing. Students mislead this. So that is why I have taken this option as well. Now talk about A. Summation 1, 2, 4, 7, 8. 1, 2, 4, 7, 8. क्या क्या given है? Summation 1, 2, 4, 7, 8. 1, 2, 4, 7, 8. 11, 13, 14. Dear 0 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 triple 1 8 यहाँ लिखा 1 triple 0 1 0 0 1 1 0 1 0 1 0 1 1 double 1 double 0 1 1 0 1 1 1 1 0 1 1 1 1. अब देखो टिक मार्क करते हैं. क्या क्या गिवन है? 1 2 4 7. This is correct. For 3 input 1 2 4 7, they are the XOR. Then क्या given है? 8 11 13 and 14. Okay, now look into this. Odd number of ones. Yes, odd number of ones. जहां even आया वहां 0 कर दिया. Odd number of ones, odd number of ones, even number of ones. 7 भी है. 7 अच्छा 5 नहीं है. This is the 7 only. This is even number of ones. Okay. Again odd number of ones. Again odd number of ones. Even. Odd number of ones. Tick mark. Even number of ones. Odd number of ones. Odd number of ones. Even number of ones. Perfect. Perfect. Output is high whenever if input contains If input contains what? Odd number of ones. Odd number of ones. So yes, it is XOR. Yes, it is XOR. So A is the correct answer. D is the correct answer. The correct answer for the MSQ question is A and D. This can be a 2-marker type MSQ question because they have checked the circuit level knowledge as well, XOR knowledge, basic NAND knowledge, right? It is the A and D is the correct answer. C is a close answer, but that is the reverse. Actually, it is a binary to gray code converter given, not the gray to binary. Is that okay, everybody? Chalo, cool. Okay, no problem, guys. Next question on your screen coming up here. Okay, right. Now, next very important, the circuit implementation using the NAND and NOR. The circuit implementation using the NAND gate and the NOR gates. The circuit implementation using the NAND and the NOR gates. NAND and the NOR gates. Okay, now I'll not tell you any theoretical illustration here. I'll give you the shortcut method which has to be applied, which will help you enable you to solve the problem. How many 2-input NAND gates are required to implement ABC plus AD plus C bar D bar? All of these questions by default assume that, even if not mentioned, by default assume that variables are available only in the true form. Dear, the variables are available only in the true form. Then tell me how many 2-input NAND gates are required to implement this. Achha. Now, there is one simple thing that you must observe. Dekho. Let's go back. Look into this, guys. When I want to talk about product terms, when product terms are there, okay, product term means AND gate. And if you have to represent product terms, if you have to represent min terms or product terms, okay, which will require AND gates, so which of the gate is preferable? NAND gate is preferable because that is less than number. 2 NAND gates are sufficient for AND gate, but NOR gates will be 3. Arey yaar, look into this, guys. Suddenly some voice issue comes and we are distorted. I'll check out, guys. Just don't worry. I'll check out. Okay, let's go back to the question. And similarly, if I want to talk about a OR gate, okay, if I want to implement the sum terms which requires OR gate, for OR gate, the NOR gates are preferable because there are only 2 required, but NAND gates will be 3 required. ठीक है? So इसको ध्यान रखते हुए I will place down a simple conclusion for you that to implement SOP expressions, NAND gates are preferred, right? NAND gates are preferred. To implement product of sum, where some terms are there, NOR gates are preferred. NOR gates are preferred, right? NOR gates are preferred. Check करते हैं. How many 2-input NAND gates are required to implement ABC plus AD plus C bar D bar? ABC plus AD plus C bar D bar. Okay, let us see now. Now, because only 2-input gates are needed, NOR gates are preferred. NOR gates are preferred. Let me just check the voice. Let me just check that voice for a moment. हेलो 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 ठीक है. Now, because only two input gates are specified, first let us draw the AND OR structure of this, right? A, B, C, this only two input gates are mentioned. So first implement AB, dear. First implement the AB, then implement the ABC. So next one more AND gate will come. That will be ABC plus AD. So there is one more AND gate to implement the AD, and then there is the C bar D bar. There is the C bar D bar. All of this to go to a OR gate, but again only two input gates are specified. Only two input gates are specified. So I will be first doing the OR of here, and then this will be ORed eventually. This is the output F. This is the basic AND OR structure. This is the basic AND OR structure. Correct? All of this to go to a OR gate, but again only two input gates are specified. This is the basic AND OR structure. Now let us see how many NAND gates will be required. So now, how do you convert to NAND gates? How do you convert to NAND gates? So little bit, one more review about this. Okay, how do you convert to the NAND gates? So what exactly NAND gate is? What exactly NAND gate is? F is equal to A into B whole bar. So there are two ways of implementing the NAND. There are two ways of implementing the NAND. Okay, A into B whole bar, right? This is the input A, B going to AND, and then which is bubbled at the output. This is AB whole bar. There can be one more way. F is equal to A into B whole bar, according to De Morgan's, is also A bar plus B bar. That is also equal to the A bar plus B bar, right? Plus means a OR gate. Plus means a OR gate, but there is a OR gate which should be bubbled at the input. There has to be a OR gate which is bubbled at the input. There has to be a OR gate which is bubbled at the input, and this also behaves as a NOR gate. Okay. So AND gate bubbled at the output or OR gate bubbled at the input is a NAND gate, we can say like that. Now I want to convert this particular circuit into NAND gate. So what should I do? I will place the bubbles at the AND gate output. Pay attention here. I will just place the bubble at all the AND gate output. I will place the bubble at all the AND gate output. Is that okay? Because whenever I place a bubble at the AND gate output, it becomes a NAND gate. But there are some OR gates also. What to do with the OR gates? With respect to OR gates, I will place the bubbles at the input. Okay, then that also becomes a NAND gate only. So whatever the OR gates are here, I will place the bubbles at the input. I will do what? I will place the bubbles at the input. That also becomes what? That also becomes a NAND gate. So I have converted every AND or OR gate into a NAND gate, right? Any doubt up to this point, please let me know. There are some OR gates, right? Now, how many NAND gates till now? How many NAND gates till now? Sir, 1, 2, 3, 4, 5, 6. Wait a moment. These are 6. Okay. But I told you variables are available only in what? Variables are available only in the true form. That means C and D are available. But my function is asking me to implement C bar D bar. C bar D bar is not available. C bar D bar is not available. So I have to design C bar D bar. How to design C bar D bar? Through NOT gate. For a NOT gate, how many NAND gate is required? For a NOT gate, how many NAND gate is required? 1. So this is NAND gate number 7. This is the NAND gate number 8. Is that okay, everybody? This is the NAND gate number 8. Okay, ये जो inverter है ना, this is this NAND gate. How do you implement the inverter using the NAND gate? Something in this form that I have already explained. So 1 NAND gate here, 7 and 8. Is the story over? The story is not yet over. The story is not yet over. You have introduced inverters in the system. You have done what? You have introduced the inverters in the system. And since you have introduced the inverters, dekho, I told you to place the bubble at AND gate output. Bhai, you have placed the bubble. What is a bubble? It is an inverter. You have simply put inverters in between that can spoil the functionality, that can change the functionality. I want to implement the same function using NAND gates, not any other function. So you have some inverters introduced in between which were not there. But luckily, ध्यान देना, luckily, look into this. These two inverters have come up in series. These two inverters have come up in series. You have placed two inverters, but they are in series, so they will cancel each other, na? They will cancel each other. What will the inverters in series do? So if this is x, this is x bar, this is x bar ka bar, that is equal to x, so that the functionality doesn't change. Now the functionality doesn't change. Now the functionality doesn't change. So they cancel each other. Similarly, this is in series. So you have to find if they are in series, they cancel each other, right? This is also in series, they cancel each other, right? But this is not in series with anything. This is a single inverter you have introduced. Now, because it is a single inverter, it is your duty to introduce one more inverter. Your duty to introduce one more inverter. What? One more inverter, so that the logic doesn't change. One more inverter, and this is that one more inverter. My NAND gate number 7, 8, this is 9. Right? Similarly, is there anything left alone here also, right? Here also, this is a alone bubble. So here also you have to introduce one more inverter. That is going to be your NAND gate number 10. That is going to be your NAND gate number 10. So there are total 10 NAND gates required. There are a total of 10 NAND gates required. कुछ तो flaw है option में. Answer is 100% 10. Answer is the 100% 10. Don't worry. Correct? Answer is 100% 10. Clear everybody? This is how you do it. This is how you do it. Next question बोल रहा है, how many NOR gates are required, right? How many NOR gates are required? So similarly, before I give you the answer, let us once again see the NOR gate, which is A plus B whole bar, but by De Morgan's, that is also A bar, B bar. By the De Morgan's, that is also A bar, B bar. So the basic NOR gate you all know, A plus B ka whole bar. That is known as the A plus B ka whole bar. A plus B ka whole bar. Okay. The technique is for minimum only, Sai Charan. Okay. The technique is for minimum only. Okay. But that is also A bar into B bar. Into means an AND gate can also be used, and the input should be complemented. That means bubble should be there. This becomes A going to bubble A bar, then B going to bubble becomes B bar, then you multiply. This is also a NOR gate. So there are two ways of writing the NOR gates, right? Yes, we make around 80-85%, all important things of the subject. So like end moment पर जितना revise होना चाहिए, that will be 100% done, Vivek. Almost 80-85% of the syllabus, I can say. To be very honest, I'm telling you, Vivek, है ना? So A plus B whole bar, or this is equal to A bar, B bar. So how do you convert any gate into a NOR gate? If it is a OR gate, place the bubble at the output. If it is an AND gate, place the bubbles at the input. Place the bubbles where? Place the bubbles at the input. Place the bubbles at the input. That will behave as a NOR gate. So how many 2 input NOR gates are required to implement A bar plus B into A plus C plus D? Again, 2 input. Again what? Sir, 2 input. So let me first draw the basic gate diagram. A bar plus B. A bar plus B. Variables are available. A bar plus B. Sorry. Variables are available only in the true form. Variables are available only in the true form. Complement has to be derived separately. Then A plus C plus D, and that too only 2 input gates. So A and C liya pehle. A plus C. Then I am going to implement D. A plus C. Then it will be A plus C plus D. Okay. And then these two should be multiplied here. This is the output F. Now tell me what to do, dear. Now tell me what to do. The same method like the previous question. This has to be implemented using NOR gates. And NOR gates के लिए क्या करना है? Once again, quick revision. Bubble at the output of OR gate, bubbles at the input of AND gate. So first let us convert all the OR gates into NOR gates by placing the bubbles at the output. Bubbles at the output. Then let us convert all the AND gates into NOR gates by placing bubbles at the input. Bubbles at the input. Okay. Now dear, till now how many NOR gates? Sir, number 1, number 2, number 3, number 4, number 5. This is an inverter. This also has to be built using a NOR gate only. Everything using NOR gate. And this is the inverter. Using the NOR gate. This is number 5. And then see for potential cancellation. So this is a cancellation. So no extra gate is required. Bubble in series. No extra inverter required. But this is a single bubble. This is a single bubble. So yahan pe one more extra inverter. One more inverter to be placed here. This becomes kitna hua tha? This becomes number 6. Rest all is sorted. Rest all is sorted. So answer is 6. Now, when you have given the correct answer, you have got hold of the method. Answer is the B, that is equal to 6. Answer is B, that is equal to 6. That is equal to 6. That should be equal to what? That should be equal to the 6. Perfect. Clear hai? That is equal to the 6. Now tell me this answer. The Boolean function a plus bc is to be implemented using 2 input gates of only one type. What is the minimum number of gates required? The Boolean function is to be implemented using 2 input gates of only one type. What is the minimum number of gates required? What is the minimum number of gates required? Tell me. Which gate? They haven't mentioned. Okay, Boolean function a plus bc is to be implemented using 2 input gates of only one type. Use any 2 input gate. Use any 2 input gate. But which gate? You have to decide and tell me. You have to decide and tell me. You have to decide and tell me. Using 2 input gates of only one type, dear. What? Of only one type. Only one type. Can it be AND gate or OR gate? No. If you talk about basic gates, na dhyan dena. If you talk about basic gates, this can be implemented only using AND gate. This can be implemented only using OR gate. So एक gate से तो नहीं हो सकता. Basic gate is not the solution. Think about universal. Think about universal. Right? Think about universal. Now A plus BC. A plus BC. Implemented using 2 input gates of only one type. What is this type of expression actually? What is this type of expression actually? This is product term and then you add it. So this is SOP and SOP के लिए क्या prefer करें? NAND should be preferable. SOP के लिए NAND should be preferable. Now how many NOT gates? How many NOT gates? How many NAND gates actually? तो पहले implement this A, then B and C. पहले write down the basic gate diagram. Now within the basic gate diagram it is very clear. Within the basic gate diagram, it is very clear that if I use the basic gate, it is one OR and one AND. It cannot be one type gate. 2 gates are required. That is why I have to go to universal. Universal means NAND or NOR. SOP expression hai, I will prefer NOR. Okay. And now, same technique like the previous question. Place the bubble at all the AND gate output and place the bubble at the OR gate inputs. This is, as of now, dear, 1 NAND gate. This is 2 NAND gate. AND के output पे bubble और के input पे bubble, both are known as the NAND gates. Both are known as the NAND gates, right? So 2 NAND gates, but this is a single bubble. So 1 extra inverter here. 1 extra inverter. That is going to be count number 3. No need to draw the inverter and show. You don't have to show it to everyone. You just have to calculate that answer. Right? This is 3. So total answer is 1, 2, 3. That's it. The total answer is 3. 3 what? NAND. Number of gates. They have not asked you what, but you have to decide what gate. That is NAND and that will be 3. There can be one more way of solving this question. There can be the one more way of solving this question. Y is A plus BC. Applying the distributive law, you can write down Y equal to A plus B into A plus C. A plus B, A plus C. Then you will require, you try it yourself. Then you will require 3 NOR. Because it is the POS form now. Product of sum. A plus B sum, A plus C sum, it is sum. Then you multiply product of sum. For product of sum, you will require 3 NOR gates. You will require 3 NOR gates. Okay. POS है, तो NOR होगा. And how many NOR? 3 NOR. Please try it yourself. Try this in the homework. You will get it easily, 3 NOR. So you can implement using NOR gates also, but no, just applying a distributive theorem. So answer anyways is 3. Anyways is 3. Okay? Now tell me the next. Minimum number of NAND gates required to implement a Boolean function A plus AB bar plus AB bar C. Tell me, dear. Tell me the answer for this. Tell me the answer for this question. A plus AB bar plus AB bar C. How many? It's a question to fool you around. It's a question to fool you. Yes, A plus AB bar plus AB bar C. You will start drawing the diagram. You will start calculating. But अगर थोड़ा सा logic apply किया, okay, I can take the A common. I can take the A common, and 1 plus anything is 1. So my answer is just equal to A. Given the input A, the output is also A. Given the input A, the output is also A. So what do you need to implement this circuit? Just a wire. Whatever is the input, it's the output. You don't have any gates required. So answer is 0. A question to fool you around sometimes. Question to fool you around sometimes. ठीक है? अच्छा, similarly, if I ask you, this was A plus AB bar plus AB bar C, this was A plus BC. If I ask you one more stuff here, if I give you A plus A bar B, then how many gates will be required? Tell me how many NAND will be required? Tell me how many NAND will be required? So तब आप क्या करोगे? So Y is A plus A bar B, that is A plus B. A variable and its complement multiplied by B, so complement is omitted. Complement is omitted. Now A plus B is a OR gate, right? For OR gate you need 3 NAND. That is already discussed, yaar. You can use that result. So answer is 3 NAND gates. Answer is 3 NAND gates. Here we need 3 NAND gates. Clear? So sometimes, be very specific about can you solve it using the Boolean theorems as well. You need 3 NAND gates. Done hai? Minimum 3 NAND gates. Chalo. Now see a question based on universal logic. A question based on universal logic. A 2 marks question in GATE 2022. A 2 marks question of GATE 2022 talking about the universal logic. They are asking you design a new gate. Consider a Boolean gate whose name is D, where the output Y is related to the input as A plus B bar. A plus B bar. So what should be the type of gate? This is a type of gate given, where plus denotes the logical OP operation. The Boolean input 0 and 1 are also available separately. Using instances of only D gates and input 0 and 1, NAND logic can be implemented, OR logic cannot be implemented, NOR logic can be implemented, and logic cannot be implemented. Which of the option is true? You have to tell me. MSQ question hai. Which of the option is true? A plus B bar. A plus B bar. It's a gate given whose output is A plus B bar. Whose output is A plus B bar. Can it implement a NAND logic or NOR logic? If it is able to implement NAND or NOR, it can implement any other thing. It can implement any other thing. देखो, सबसे पहले I will show you the instance of this behaving as a NOT gate. Okay, to make it behave as a NOT gate, let me draw that gate once again here. This is the gate known as D. Okay. Now, can I implement the NOT gate here? Right. NOT gate is very easy to implement. Just short the top input, ground it, and apply A in place of B. Let this be A. This output will become how much? this output is going to become 0 plus a bar, 0 plus a bar, that is the a bar actually. So this one is a bar, 0 plus a bar, that is equal to a bar. That is equal to what? A bar. So NOT gate is possible. NOT gate is possible. Now can I take it as a NAND gate as well? Now can I take it as a NAND gate? So ध्यान देना, using the same terminology, देखो, I have a bar, ध्यान देना. Now let me take a bar here. How to take the a bar? Already I have shown. Let me just redraw that. A applied here. This will give me the a bar, right? And then I take another D gate. Second input will be B. The first input is a bar. So what is this? A bar plus B bar. A bar plus B bar is also known as AB whole bar, and that is a NAND. So NAND logic can be implemented. This is very clear. NAND logic can be implemented. NAND logic can be implemented. No doubt in that. No doubt in that. NAND logic can be implemented. NAND logic can be implemented. True. If NAND can be implemented, तो OR and AND can be implemented. ये तो हो गया false. If you have NAND gate, na think yaar, NAND gate is a universal gate. You know, it can implement any of the basic gate. That NAND gate can implement OR. That NAND gate can implement AND. अभी तो मैं NOR की बात ही नहीं कर रहा हूँ. So 100% B and D are wrong. A is correct. C के बारे में check करना है. Can you implement NOR? I'll tell you how. Can you implement NOR? Okay. So let's see the next instance here. Let us see the next instance here. Right. NOR means A plus B whole bar, na? A plus B whole bar. So I'll take an inverter first. I'll take an inverter first to invert B this time. To invert what? B. This is grounded. Here I apply B. Here I apply B. I get B bar. Right. Then I take another D gate. Here I take another D gate. Right. I feed B bar here and I feed A to the first input. So what is this? A plus. Dear, what is this? A plus B bar ka bar. B bar ka bar. That is A plus B. Hey, what is this? This is actually A plus B. Now NOR gate means A plus B whole complement. So there is an inverter already ready for you. Again another D gate. Again another D gate as an inverter. Right. The first input is grounded. Second input is A plus B. So this is going to invert A plus B. A plus B whole bar, and hence this is a NOR gate. So NOR logic can also be implemented. NOR logic can also be implemented. These are good logical questions in the gate examination. So NOR logic can also be implemented. True. So what is the correct answer? A and C. Dear, if it is able to implement NAND and NOR, so OR and to anyways done, na? Anyways done. So B and D will be wrong. B and D will be wrong because B and D say that OR cannot be implemented and cannot be implemented, but it can be implemented. Right? No, Hindu. Option B is wrong. I'm telling you OR can be implemented. But question kya? Option kya bol raha hai? OR cannot be implemented. So that is why it is false, na? It can be implemented. Don't worry. Right? Done. This is what it is. Okay, now you see this is a gate 22 2 marks MSQ question. So be very careful, be very watchful about such questions regarding to the universal logic as well. And dear, before we move ahead, a reminder that to cover up, to take up your responsibility for aptitude as well. Yes, I will be coming live. Okay, to ensure your 15 marks in just 15 hours, a 15-hour session to ensure your 15 marks. Okay, coming soon. Coming soon. After the technical marathons, general aptitude, all branches. This is coming soon. Stay tuned and stay subscribed to the channel so that you don't miss it. If you are subscribed, you will get the regular updates, regular notifications. So do not forget to subscribe to the channel so that you don't miss this important event, and not only the general aptitude. Similarly, to ensure you that nothing is impossible, the complete non-stop maths marathon will also be there to make your complete syllabus coverage in 2 days. This is also coming soon. So mega events are coming soon for you, right? Mega events are coming soon for you. Let's move ahead to the next case then. Okay, now let me first, before talking about any other type of question, let us first quickly go to the K-map. Let us first quickly go towards the K-map discussion, the 3-variable K-map, dear. Okay, the 3-variable K-map. Okay, let's start this, guys. Mostly all, Chandra, mostly all. Okay, so 3-variable K-map. Okay, so we know that the K-map will follow always the gray code, so that in the BC we have 0, 0, 0, 1, 1, 1 and 1, 0 to ensure that there is only 1 bit difference between the consecutive boxes, and then that consecutive boxes can be paired, and this corresponds to 0, 0, 0. Now what is 0, 0, 0? Now this color doesn't look fine. What will perfectly fit inside? This is visible? Yeah, this is better. So 0, 0, 0 is going to be a min-term 0, 0, 0, 1, then 0, 1, 1, 3, 0, 1, 0 will be 2. Similarly, 1, 0, 0 will be 4, 1, 0, 1 will be 5, 1, 1, 1 will be 7, and 1, 1, 0 will be 6. So last 2 columns will always be swapped. Yes, FSM problems will also come, don't worry. FSM problems will also come. We will cover that also. Just stay tuned for both the days of digital. The M0, M1, M2 and M3, M4, M5, M6 and M7. The last 2 columns will be swapped in in any K-map. Let's take up the basic 3-variable, then go to the 4-variable as well. What is the Boolean expression for the truth table shown? What is the Boolean expression for the truth table shown? For the truth table shown here. What will be the Boolean expression for the truth table shown here? Tell me. Boolean expression for the truth table. Now, it's given in the form of truth table, and I can see that the function is I at 0, 1, 0, 0, double. What I'll do, I'll quickly feed this into the K-map. I'll quickly feed this into the K-map and get hold of the minimized expression. Get hold of the minimized expression. Okay, so let's say this is A, this is BC. Always mark up the regions. Now see, this is, I'll mark up the regions here separately. This is the entire row where A is high, and A is high means I'll write down A. Whenever A is low, whenever A is 0, we write down A bar. So other one will be A bar. Similarly, in the BC, B is high at these 2 combination, right? B is high at these 2 combination. So in these 2 columns, B will be represented. Similarly, C is high in the center 2 combinations, right? So center 2 columns will be the region specified for C. Okay, so now if I come and fill this K-map, first of all, first make the entries of the K-map. So 0, 1, 0, that is 2 and 3. This is min-term 2, min-term 3, then 5, 6, 7. 2, 3, 5, 6, 7. This is 2, this is 3, then 4, 5, then 6, and then 7. And then you have to talk about the possible pairing or grouping. I've plotted the region again. So what is the first possible group? It's a quad, and try to make larger groups, quad. And then this one, don't leave it alone, you can pair it up. Okay, you can pair it up. So what is this pair? This is A and C. This is with A, with C. Completely within A and C. What about this quad? It is completely fitted within the B. So this is equal to what? This is equal to the B. And so your output will be equal to the AC plus B. Your output will be equal to what? The AC plus B. Okay, that is the option number A. Very simple. That is the AC plus B. Any confusions in pairing or how I am reasoning it up, you can be free to ask. You can be free to ask. Right. Similarly, if I take the 4-variable, and then let's take the mixed example. If I go to the 4-variable K-map and fill up these entries, so AB, again there will be gray code in AB, 0, 0, 0, 1, 1, 1 and 1, 0. Similarly, CD I write down on the top again with the gray code 0, 0, 0, 1, 1, 1 and 1, 0. So that this is M0, M1, 0, 0, 1, 1 is M3, 0, 0, 1, 0 is M2. So again the last 2 columns will be exchanged, always because of the gray code. Similarly, this is going to be 4, 5, then 6 at the last, and then I will have the 7. And then I will have the 7. Right. Now, next. 1100 is actually 12. So suddenly 12 comes here. Look into this. 1000. 1000 is actually the 8. So this is M8. 1000. That is known as the M8. So again, you are able to feel that the last two rows are also exchanged just because of the gray codes only. Okay. So if this is 8, then 1001, this becomes the 9, 1011, 11, 1010, 10. So again, 10 last and then 11 before, exchanged. This is similarly 12, then write down 13, then this will be 15 and then 14, exchanged. If I want to specify regions, this will be A. B is high at these two columns. So I'll write down here separately, this is B. Similarly, this will be C. Dekho, C and C is high here. And similarly, center two combinations, D is high. Center two combination D is high. So this is known as the D. This is known as the D. So we have A, B, C, D. We have the A and B and C and D. We have the A and the B and the C and the D. That's it. Okay, chalo. This is the ABCD. Clear? This is known as the ABCD. A, B, C and D. Now, let's take up a simple example. Okay, 0, 2, 3, 4, 6, 8, 9, 10, 13, 14, 15. Let's fill it up quickly. Let's fill it up quickly first. Okay, and let me also specify. Okay, this is AB, this is CD, this is going to be A. Everybody try to answer this quickly. This will be B. This shall represent C, and this is going to represent D. And now let me fill the terms as well. So what are the terms? 0, 2, 3, then 4, 6, 8, 9, 10, 11, 12, then 13, 14, 15. These are the ones plotted. These are the ones plotted. Come on, everybody. Right. Yes, yes, Raghu. Tell me. Yes, tell me, guys, everybody. So see, what are the groups that you are able to form? First, form that group. So this is clearly a quad. There is no octa possible here, I think. Yes, this is clearly a octa. Now, these two ones, can you take it separately? Why to take it separately? This can also be made into a quad. Okay, but this particular one, this is alone. This is alone. So this can only be paired. No other consecutive things. Okay. What about this one and this one? What about this one and this one? These two are still left. Okay, so these two can be paired. You can pair these two also and these two also. That is also a possibility. That is also a possibility. Okay, and these two can be further paired. These two can be further paired. Right. देखो, what is one more possibility that you can do, but जो need नहीं है यहाँ पे? I'll tell you that also very specifically and very strictly. Okay, I'll tell you that also very strictly so that you take care of it. So that you take care of it. Okay, sometimes you may pair it with the corner one so that corner ones are adjacent. You'll make a quad. Okay, but then for this particular one and for this particular one, anyways, you need two pairs. Okay, or you can take the pairs like this. But anyways, you need two pairs here. And because you need the two pairs here, okay, that quad is waste because if two pairs are anyways needed, why to not take it like this? This also represents two pairs only, na? This also represents two pairs only, Chinmay. So that quad then actually not required. Then that quad is actually not required. That quad will just go into waste. That quad will just go into waste. Or if you are taking that quad, maybe you can remove this quad. ये वाला pair ले सकते हो. Right, and this can be already into quad. Yes. Okay, so only one of that quad will be required. Okay, only one quad will be required. Now, what are these quads and pairs naming? Clear everybody? Any confusions? Please let me know. So, what is this? This is A bar, A ke bahar hai, B ke bahar hai, and within C, A bar, B bar, C. Then this particular quad, that is C and outside D, C, D bar. This particular quad, okay, this particular quad, this is outside A and outside D, that this is A bar, D bar. Then you have two pairs, right? Then you have the two pairs. So what is this? A, B bar, B ke bahar hai, C ke bahar hai. A, B bar, C bar, and last is this one, that is A, B and D. Got this everybody? So your answer here would be, C, D bar, then A bar, D bar, A bar, B bar, C, A, B bar, C bar, A, B, D. Yes? Tell me for any confusions. Right. Aega don't care will also come, Raghu. Here it is the question with don't care actually. F is equal to summation of the minterm 0, 3, 6, 7, 9, 14 plus the don't care conditions. Again, I will mark the AB here and the CD here. AB and the CD, right? This as A, B, C and D. Right? Explain that at ABC. ABC kahan pe hai? No, there isn't any ABC actually. This is A, B. No, there isn't any ABC. Please specify, Ashok, your doubt clearly, what term you are looking for. Okay, chalo, yeah. Let's come here for that moment. So let's fill up summation of the minterms. What are the minterms? 0, 1, 2, 3, then 6, 7, then we have 8, 9, 12, 13, 14, 15, then there are don't cares. 1, 4, 5, then 8, 9, 11, 13, 15. Now, what is a don't care? The don't care can be treated as 1 or 0. The don't care can be taken as 1 or 0 as per your need, as per your convenience. So, what will be convenient now? What will be convenient now? Okay. The don't cares can be taken as either 1 or 0 depending on how it is helping you in minimization. So dear, if I take these don't cares equal to the 1, suppose if I take the don't cares equal to 1, this is clearly a octa and the bigger group will reduce more variable. Okay, so definitely from here I make a octa assuming all the don't cares equal to 1. Okay, now what is left? These two 1, right? It is necessary to combine all the ones, but if you take it as 1, it becomes a pair. Already this don't care is assumed to be 1. So then this can also be clubbed using a quad. This is a quad. Only a single one is left, right? If you don't treat this don't cares as 1, right, then this is a single one. It will be a minterm. It cannot be combined. But already these two x are taken as 1. Isko bhi 1 maan lo. So this again becomes a quad. Right? So you can treat x whatever. Some of the x may be 1, some of the x may be 0, whatever you want. Here all x are equal to 1. Okay, so this is a quad which is fitted in BC. This is the octa. Now see, this octa, it is only fitted within the D. So that is D. Take Ashok, learn here again. You have to see that whether that quad or octa, whatever it is, Ashok, where it is fitting. It should completely fit in or it should completely fit out. I don't take 50-50%. Like look into this particular quad. This is A, so this is outside A. I write down A bar. Now look into this. This is D. So it is 50% D, 50% out of D. I don't take D then. Either it should be totally in or totally out. Now this is C. It is totally away from C, outside C. So I will write down C bar. Similarly, B may, it is 50% inside B, 50% outside. So I don't write down B. Is that okay, Ashok now? So what is the output then? It is A bar, C bar plus the BC plus D. Check your answers and let me know if that is okay. Right? A bar C bar plus BC plus D, right? One more condition with don't care. Please check and let me know. One more question with the don't care. Let me draw the K map here first. Let me draw that K map here first. ठीक है जी. This is AB, this is CD, right? A, B, this becomes the C, this becomes the D. ठीक है. चलो, so let's fill it up, guys. Let's fill it up and get hold of the answer. Let's fill it up and get hold of the answer. Start करें. So what it is? What it is? What it is? What it is? Let's fill up this. Let's fill up the minterms first. 0, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then the don't cares are 2. Sorry, this should be 2. Then you have 4, and then you have 10. 10 is here. These are the don't cares. Now see the possibilities. Now see the possibilities. Very clear possibility is that this cannot be grouped anywhere. This cannot be grouped anywhere. This doesn't have any adjacency. This is the minterm number 13, 12, 13. 13 is 1101. 13 is 1101. A, B, C bar D. ये तो आना ही चाहिए. A, B, C bar D. My answer is B. Finish. This is compulsory there. This cannot be reduced. This cannot be reduced. Are you getting it? This cannot be reduced at any cost. So answer is B. Rest you can again reduce. Okay, what is the rest? These two ones, these two ones, these two ones. So you can take a quad here for these two ones. Don't take the pair, better take the quad. Okay, so this quad is within C and outside D. Within C and D ke pura bahar. So CD bar, that is also coming. Perfect hai. CD bar is coming, and then this one is left, but don't take it alone. Don't take it alone. Don't pair it up. You can make a quad. These two and these two. Or you can take the quad of corner ones. Okay. यहाँ पे I think the option is given according to the corner ones. Yes. So I will take all 4 corners. We should know that all 4 corners are also adjacent. Right. So all 4 corners. Now see, this is B. Corners are outside B. Similarly, this is D. Center 2. We have corners outside D. So this is known as the B bar D bar. Option number B. Okay. There can be multiple answers. There can be again voice glitch. Okay. I think the option is given every 30 minutes there is a pattern, no problem. I will again rectify it. By that time I'll give you a question. Don't worry guys, I hope this is clear. By that time please try one more question here. Yeah, please try up this question. I'll just recheck it. K-map for a Boolean function is given and the options are in the form of. Have a look into this. All the options are what type of option? Product of sum. POS form are in the option. How to solve POS? How to solve POS? How to solve POS? Tell me. By that time I'll just rectify. I'll just recheck it once again. Chalo guys, let's check it up again. Okay, so POS form में लेना है answer. So what I'm going to do here is I'm going to first of all take the K map for the F bar. I should draw the K map for the F bar. So whatever are the missings, that will actually become 1 here. Okay. Missing means जो 0 है वो अब 1 हो जाएगा. This is 1, 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 and this is 1. And whatever are the ones given, that will become what? That will become the zeros. I'll remove it. The ones that are by default given, they will now be 0. This is removed. Is that okay now? Is that okay now? So now next is I will start grouping and pairing once again. So this is clearly a quad in front of me. This is clearly a quad, and the 4 corner ones can also be grouped, right? So now look into this. This is WX. So first W and then X here. Then next you have the variable YZ, like CD. ABCD will be replaced with WXY and Z. Okay, dear. What is this? This is the corner ones, outside X and outside Z. This is X bar, Z bar. Okay, and this particular quad, it is in W very clearly, and it is outside the Y. This is Y and this is outside the Y, WY bar. But this is the K map for the F bar. So what should be F bar equal to? F bar is known as X bar Z bar plus WY bar. So what is F? De Morgan's, one single step, X plus Z, W bar plus Y. X plus Z, W bar plus Y हो गया. X plus Z, W bar plus Y. X plus Z, W bar plus Y. Answer is B. That's it. Very simple, very easy now. X plus Z, W bar plus Y. This is done. So POS form also can be obtained by taking the K map for F bar and then 5 seconds extra. That is the De Morgan's law. That too, De Morgan's is very simple because we have learned the duality wala method. De Morgan is very simple because we have learned the duality wala method. We have learned what? We have learned the duality wala method. Okay. Okay. Chalo. Next question. F is equal to summation of the minterms 1, 5, 6, 7, 11, 12, 13, 15. A special case of the K map. Okay. Let's fill this. Let me specify the regions. This is A and B, and then this is the C and this is the D. Okay, let me specify here. So 0, 1, 2, 3, then we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. अरे कुछ मिस हुआ क्या? What is not given? 8, 9, 10, 11, 12. Okay. Now see guys, what is the group you are going to form? You will actually first of all have a temptation actually to make this as a quad. सबसे पहला temptation आएगा quad लेने का. Right? Okay. So you will try to take it as quad, but then see what happens. Now, forget the quad. Talk about this one. This can be paired only with the bottom one. Okay, so इसके लिए तो एक ही possibility, you will take it as a pair. Similarly, this will be pair. This has to be paired, and this left वाला, this has to be paired. So you have minimum 4 pairs. Now tell me whether the quad is required. Whether the quad is now required. If you take 4 pairs, all the minterms are covered. Why to unnecessarily take the quad and introduce a term? You have to minimize the function. By introducing one more term, you will have an additional term. Good afternoon, Sandhya. Is that okay? So do you require that quad now? This is the exception case where the larger group quad will be not required, right? And pairs will be sufficient. Pairs will be sufficient. Is that okay, everybody? Is that okay? Write down, you can write down the name of the pair. And that is where the concept of, prime implicant and essential prime implicant also comes. Okay, what prime implicants are, what essential prime implicants are. With this, let us quickly also talk about, you can write down the expression later on, okay? You can write down, that's a homework for you. But with this only, let us quickly link the concept of prime implicant as well as the essential prime implicant. Okay, what are the essential prime implicants and prime implicants? Okay, let us start with the 3 variable example first. F is equal to summation m 0, 2, 3, 5, 7. 0, 2, 3, 5, 7. 0, 2, 3, 5, 7. Quickly, everybody. Right? Do you need a break, guys? Do you need a break, guys? I think students are now a little bit looking into search of break. मुझे ऐसा feel आ रहा है. Right. K-maps are already discussed, no, Suparna? That's what we were looking. Okay. Dekho. Now 0, 2, 3, 5, 7. Let's talk about this 3 variable map once again. This is A, B, C regions. And let me fill up this. Okay, we have 0, 2, 3, then 5, 6, 7. Now, what are prime implicants? What are essential prime implicants? Dhyan dena. What are the prime implicants? What are the essential prime implicants? Prime implicant means any product term that you can extract from the K-map. I'll tell you in the shortcut method, like we did the NAND and NOR methods. Here are the official definitions also. A product term implicant is a prime implicant if it cannot be combined with any other ones. If it cannot be combined with any other ones. Simply what you have to remember, every possible pair is a prime implicant. So, prime implicant is a puzzle. Yeah, we'll give you a break shortly. Okay, but this is a very important topic. First, let's focus this. This is like a puzzle. Prime implicants are like a puzzle. Puzzle में क्या करना है? Find out all possible pairs. Not only pairs. Not only pairs. It could be pair or quad or octa or anything. Whatever you can search. Every possible group I should write actually. Right? Every possible group. So it's a puzzle. How many groups you can find? But the condition is कि, suppose, listen to me. This is a pair, everybody. But suppose there was one more one here. Suppose there was one more one here. So will you take it as a pair? No, then you will not take it as a pair. Then it will be a quad. It is a prime implicant if it cannot be further combined. सबसे पहले क्या बोला? If it cannot be further combined. Okay. So you have to search largest group. Not every possible group. Largest possible group. Largest possible group. Okay. Cyclic वाला भी तो discuss किया सुपर्णा. Right. Largest possible group. So if there is a one here, then this will be taken as quad. Right now there isn't any one. So how many groups you can find here? Sir, this is a pair. Let me write down. This is a pair. Sir, this is a pair. What about this? This can be paired with the right. What about this? This is also a pair. I am telling you whether it will come in K-map or not. Don't think like that. Don't think about the K-map answer right now. Just think how many pairs, how many groups you can form. Puzzle. It's a puzzle. Can you find out all groups in this K-map? If you're able to solve this puzzle, you have got the prime implicant. So how many prime implicants are here, dear? How many prime implicants? They are the 4. What are the prime implicants? Let me write down for you. What are those prime implicants? This is AC, right? So one of them is the AC. Then what is this prime implicant? Vertical wala? This vertical one, that is known as the BC, right? Then this one, that is A bar B, right? So we have BC, we have the A bar B, and then these two corner ones, that is outside A and outside C, that is A bar, C bar. These are the 4 prime implicants, dear. These are known as the 4 prime implicants. What to do next? Essential prime implicants. What are essential prime implicants? What are essential prime implicants here? Dhyan dena. Essential prime implicant. Again, I'll tell you the shortcut. You will just start highlighting the ones. You will just start highlighting the ones. Which ones? Which are covered under a single group. Now look at this poor one. It is covered under how many groups? It is covered only one group. So I highlight this. Star mark this. I'll start by star marking it. right? Look at this one. It is covered into two groups. No. It is covered under two groups. No. This is covered under two groups. No highlighting. This minterm, it is covered under a single group. So I will highlight this as well. I will highlight this. I will star mark it. Find the minterms which are covered under a single group. Now, the group containing them is essential. The group containing them is essential. जरूरी, क्योंकि अगर मैंने इस ग्रुप को छोड़ा, एक मिनट के लॉजिक सुन लेना, अगर मैंने इस ग्रुप को छोड़ा तो ये मिनटर्म छूट जाएगा. This minterm will be skipped if I leave this group. Okay, but this minterm can still be saved. इसके पास तो second option है ना. This minterm can still be saved. Okay, but this particular minterm cannot be saved. That is why the group AC containing it becomes essential. Becomes what? Becomes essential. Okay, so AC is essential. And what else? This star mark, this was the group. इसको मैं यहां लिख देता हूं. This was the group. A bar, C bar. So that also is what? That also is essential. So how many EPIs there? Everybody, how many EPIs we have in the problem? That is 2. That is the AC and the A bar, C bar. Now a very big question comes here is, now a very big and important question that comes here is, whether the function is equal to AC plus A bar, C bar, whether it is equal to summation of EPIs, whether the function is equal to summation of EPIs. Is that sufficient? Is that sufficient? Let us draw that. Let us draw that. Let us draw that. Summation of EPIs. Okay. Summation of EPIs. So AC plus A bar, C bar. AC वाले terms को लिखेंगे तो I get these two ones. This is AC. Right. And this was A bar, C bar. Okay. This was A bar, C bar. Okay. Now, if you only take AC plus A bar, C bar, what is happening? What is happening? This is missing. Originally, in the function, there is one more minterm. Originally, in the function, there is one more minterm. This is missing. This is missing. What minterm? Missing M3. Missing the minterm number 3. And if this is missing, we need to implement. We need to include that. We need to include that. We need to include that. Include कर लेते हैं, right? So include it by what? How? Who can include this? ध्यान देना. Who can include this? Right? It is there in two possible groups. Either the horizontal wala, that is BC, or it is there in the vertical wala. Vertical wala is BC. Horizontal wala is A bar B. So you can take it either A bar B. There are two possibilities to save it. And dear, listen to me again. That is why the BC or A bar B. That is why the BC or A bar B, they are going to come in the answer, but they cannot be said as essential. Essential का मतलब होता है which is 100% coming. जो 100% मेरे साथ है. This is optional. Either BC will come or either A bar B will come. So what is my correct answer? What is my correct answer? What is my correct answer? My F will be equal to AC plus A bar C bar plus if I want I can write down BC or my F can be equal to AC plus A bar C bar plus A bar B. These are both the possibilities. These are both the possibilities. In short, what is F? It is summation of EPIs. ये तो confirm है. EPIs will 100% come. That is why we call it as essential. जरूरी वो तो आएगा ही. Plus possibly sometimes only EPIs will be sufficient. Possibly some non-essential PIs. Non-essential PIs. Very important point we are discussing here. Very important point we are discussing. So that means the total prime implicants. Okay, ये already मैंने लिखा हुआ है यहाँ पे. The total prime implicants are of two kinds: essential and non-essential. Essential and non-essential. Right. Now, out of the non-essential, some of them may be included. Right. The one which you include becomes selective prime implicant. What is this? This is known as selective prime implicant. Right. The one which you exclude becomes the redundant. Becomes what? Becomes the redundant prime implicant. Which of them is selected, which of them is redundant, depends on you and me. I can choose something else, you can choose something else. For example, ध्यान देना, in this case, BC becomes the SPI and then A bar B becomes my RPI. Are you getting it? A bar B becomes RPI if I choose the first answer. But suppose you say, sir, मेरा तो मन है, ऑप्शन था ना, मेरा मन है मैं A bar B को लूंगा, I like A bar B, right? If you select A bar B, then for your case, dear, A bar B becomes the SPI, right? BC becomes the RPI. So that is dependent, that can change situation to situation. But yeah, number is fixed. Out of the two non-essential, one will be selective, one will be redundant here. Sometimes all can be redundant. Sometimes answer is only this much. Okay. So this is what all varieties of prime implicants. First, essential and non-essential can be RPI and SPI. If you have understood up to this point, quickly start solving this. इसको छोड़ो पहले. Quickly start solving this. ये होमवर्क कर लेना. What is the number of essential prime implicant? ठीक है, इसको होमवर्क कर लेना. I'll tell you the answer tomorrow. Don't worry. But first start solving this. ये same तो नहीं है ना? 0 2. No, different. Start solving this MSQ question. If you have understood, and if you have any doubts in the SPI, RPI, EPI, PI, please tell me. Otherwise, start solving this question quickly. Okay, dear. See, Udud, nothing is like weak. Okay, many students are weak in the beginning. Many, not only one or two. Only thing is, if you really want to crack it up, just do hard work and be consistent. Only two things. मेहनत करनी है and you have to be consistent till the end. All your weakness will go away. You have to be consistent. पूरा एक दिन का हिसाब रखना है आपको. चलो, which of the following is true for the following function? And before we solve this question, here let me announce you the password. The PDF will be shared in the Telegram group, my Telegram group, Sanjay sir Telegram group, but it is going to be password protected. You will get a single PDF. ठीक है? You will get one single PDF. Right? You will get one single PDF combined today, my and Sanjay sir. Okay, but that will be password protected. We will share it by today end of day. We'll combine both the PDF, and the password for the PDF will be logic. Digital logic ka logic. Okay? So please note down this password. Don't ask the password in the Telegram groups. And the PDF, I'll share you the Telegram link once again. You can join the Telegram. You can join the Telegram group. ठीक है, चलो डन है. So let's see this question. Let's check up this answer, guys. Everybody, which of the following is true for the function? Number of PI and EPI is the question wants to discuss about. Okay, let's quickly draw the 4 variable K-map, because K-map is the easiest method to handle the PIs and EPIs. Shortcut method, you can say. Any more confusion about the PI, EPI, RPI, you can again ask me. Let this be AB, let this be CD. This is what is A. Chalo, tell me, what is this? 0, 2, 3, 5, 7. let us fill this 0, 2, 3, then you have 5, 7, then 8, 9, 10, 11, 13 and 15. 13 and 15. Now tell me, dear everybody, tell me, dear everybody, first let us make PIs, and PIs I told you is a puzzle problem. Puzzle means make all possible groups, but that should be the largest group. Okay, so this is definitely vertically agar hum dekhen, so this is one column. This is one column, right? Horizontally, this is the entire row. 4 corner ones also make a quad. So the obvious ones I'm making right now. Okay, 3 are done. Acha, PIs का list हम बनाते जाते हैं पहले, so otherwise it will be confusion at the end. So what is this? This is in A and outside B, A, B bar. This vertical one, this is within C and D. These are the corner ones away from B, B bar, D bar. So we have CD, we have A, B bar, we have the B bar, D bar, we have the B bar, D bar. और बताइए, right? Now let's move ahead. This is another one. This is another quad. This is another quad, right? Within B and within D. So that is known as the BD. One more entry here, BD. What else? Now there are 3 rows consecutive. 2 से quad बनाया. There can be one more quad here also, na? There can be one more quad here also, which lies in A and center में D. So AD, that is the next one. 5th is done. Anything else? Anything else? Anything else? Anything else? Anything else? Anything else? Tell me. Dekho, anything else? These 2 ones, these 2 ones, these 2 ones, these 2 ones also makes a quad. Also makes a quad. Okay, and what is this? This is within C and away from B. B bar C. The next is B bar C. B bar C. That's it. Okay. PIs will be 6 in number. Tell me if you have anything else. And now I will start marking the essential prime implicants. I will start marking the essential. This is alone, star mark, and this is in B bar, D bar. So this is essential. This is not alone. This is not alone. This guy is alone. This guy is alone and it is sitting in BD. The group including it will become essential. Okay, simple technique. Star mark, highlight that group. Simple technique for shortcut for EPI. This is not alone, not alone, not alone, not alone, not alone, not alone, not alone. So how many EPIs? Dear, how many EPIs will be the 2? Right, that is the B bar, D bar, and that is the BD. So there are 4 non-EPIs. But that non-EPIs can be RPI and can be SPI. Can be RPI and SPI. Okay, you have to conclude that also. Question is talking about RPI as well, whether the RPI is 1 or not. So let's see that. Let us just see that. So if I take B bar, D bar plus BD, ये मेरे को देखना पड़ेगा. If I just take the BD plus B bar, D bar, what is missing? What is taken? Just once again, let me draw this. Once again, let me draw this. So BD, B bar, D bar. अब क्या missing है ये देख लेंगे हम लोग, right? This minterm is missing. Okay, this is missing. Then what else? Second row is okay. Third row is also okay. Fourth में these 2 are missing, right? These are all missing. These are all missing. अब इसको कैसे include करेंगे? इसको कैसे include करेंगे? Right? इसको कैसे include करेंगे? This is in 2 groups. Either CD और B bar C. Right? तो इसके लिए तो आ गया CD और कौन सा बोला था मैंने? और B bar C. CD और B bar C. ठीक है. What about this one? Now these two can be combined in this horizontal complete row. That is AB bar. That is AB bar. Right. These 2 can be taken in AB bar or this wala, ye wala. What is this? AD. This is AD. These are the possibilities. Tell me. These are the possibilities. Yes. Aptitude, maths, all marathon will come Krishna Pranay, right? This is AB bar or AD. AB bar or AD. Now tell me. Okay, so from one from there. Okay, so there are, देखो, final answer. There are 6 PIs. There are 2 EPIs. If there are 2 EPIs, so automatically, 4 non-EPIs. Out of these 4, one from here, so only 2 selective, right? Only 2 SPI and 2 RPI. 2 SPI and 2 RPI. So let us see. The number of essential prime implicants is 2, correct. The number of prime implicants are 6, correct. Number of redundant prime implicant is 1, wrong. BD and B bar, D bar are PI as well as EPI, correct. EPI dekho na, BD and B bar, D bar. So the correct answer for the question is A, B and D. The correct answer for the MSQ question, dear, is A and the B and the D. A and the B and the D. The correct answer for the question is A, B, D. C is wrong. RPI is 2 actually, SPI is 2. RPI is 2, SPI is 2. Okay, because only one of them and only one of them. So one from there, 2 selected, so 2 reduced. 2 selected and 2 reduced. Okay? And one question from EPI I have given you as homework. Please try it out, guys. And now it's time for a short break. It is time for a short break. It is a time for a short break. Just for the 5 minutes. Just for 5 minutes. Because anyways, after 2 p.m. or 2:30 p.m. you will get the proper break. For 5 minutes, have water, refresh yourself, just refresh.
Hello guys, welcome to the BYJU'S exam prep. This is Sanjay Rathi. Now, 1 minute. I will continue from this part, and thank you Rakesh sir. And that is Digital Electronics Part 1. Okay, and already we have discussed number of topics. Rakesh sir have given you the idea about numbers, simple K-map, essential prime implicants, selected prime implicants, and so on. Now from this I will give you the idea about combinational circuit, that is encoder, decoder, adder, half subtractor. Most important one, that is what? Multiplexer and ripple carry adder. Okay guys, now please like the session and subscribe our channel. So how many students are attending the session? Please give me the attendance and give your response. Everyone, how is the Josh? And I think you are enjoying the session, yes or no? Okay then, so this is my introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience, and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008. I have mentored more than 1 lakh students for these competitive exams. Okay, then without any delay, this is a Maha Marathon. Already we have started with the digital. Then after that, from 4 p.m. we will start with network. Okay, so this is a complete revision for GATE 2023. So subscribe the channel and like this session. Okay guys, then without any delay we will start with what? First combinational circuit is what? Adder and subtractor. Quick revision, and then we will solve important numericals on that. So adder and subtractor, what is the important? Always remember, when we are adding these two, this is a addition actually, right? It is not a OR gate, it is a actually addition. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 0 carry 1. So in addition we are getting sum and what? Carry. Sum and carry. Or in subtraction we are getting difference and what? Borrow. Difference and borrow. There are two types of adder and two types of subtractor. One is called half adder, then full adder. Half subtractor and what? Full subtractor. ये है दो. And with the help of full adder we are designing ripple carry adder. So one by one we will discuss, and then we will solve numerical on that. This is a quick revision for all this topic. So first of all, this is a half adder. As you know, 0 plus 0, sum is 0, carry is 0, sum is 1, sum is 1, carry is 1, sum is 0, right? And that's why we are simply writing a bar b plus a b bar, that is nothing but a exclusive or with b, that is the sum, and the carry is ab. Carry is AB. This is a very simple formula for sum and carry for half adder. Then this is the diagram. This is the implementation of that half adder by using the XOR gate, that is a exclusive or with B and AB. This is a half adder. Now this is full adder. Very quickly we are revising this. Full adder means there are two digits A and B, and that is the carry. Third bit is what? Carry. Carry in, that is called carry in. So what is the carry out and what is the sum of this? So there are 3 bits, and that's why total 8 combination, that is called 0, 1, 2, 3, 4, 5, 6 and 7. Everyone tell me, what is the sum? This is the function of A, B and previous carry. What are the mean terms? Give me the answer in the comments box. And what about the carry? This is the function of mean terms. So what are the number? These are the standard mean terms for sum and carry. That will be the question in coming exam. So what is the answer, my dear friends? Right, in comments box give me the answer. Okay, very good afternoon everyone. Neha and Sheikh and Roman and Dreamer. Okay, so Neha has given the answer 1, 2, 4, 7. Very simple. ABC 0, 0. This is 0, 1. 0 plus 1 plus 0, 1. This is 1 carry 0, right? And that is 4. Sorry, this is 1. 0 carry 1. That is the sum is 1. 1, 0, 1 carry 1. Sum is 0. Carry 1. Sum is 0. Carry 1. Sum is also 1. Means what is the number? 1, 2, 4, 7 and 3, 5, 6, 7. So remember this number 1, 2, 4, 7 and 3, 5, 6, 7 for full adder, because we have to design the full adder by using multiplexer, or we have to design the full adder by using the decoder, and we have to implement the full adder by using what? 2-level implementation, that is and OR gate, right? Or by using what? Full adder by using 2 half adder and 1 OR gate. So there are different circuits for full adder. Now, so 3, 5, 6, 7 for carry and 1, 2, 4, 7 for sum. Then what is the full adder? First of all, we are designing the full adder by using the 2 half adder. Remember, here we are getting the A exclusive or with B. Now the sum is what? A exclusive or with B exclusive or with what? C. That is the number. When we are solving this 1, 2, 4, 7, we are getting the sum. So that is the A exclusive or with B exclusive or with C. And when we are solving the C, C is nothing but majority gate. C is nothing but just majority. 3, 5, 6, 7 means the number of 1 is 2 or more than 2. So this is just like a majority. And when we are solving, so C out is equal to AB plus BC plus CA. That is the C out. And here it is a C in. So this is the implementation. So we can implement the full adder by using the 2 half adder. This is the half adder and that is the another half adder and 1 OR gate. You will get the carry here, C out. And that is the previous carry, C in here, A, B, C. This A exclusive or with B is called carry propagation. Carry propagation. And we will use this term in case of look ahead carry generator. Here the product term, AI, BI, that is called GI. So this is the AI, BI and this is the CI. So here we are getting the AI, BI, this is the product term and so on. And here we are getting the carry output. Okay. So you have idea about that? Yes, 2 half adder plus 1 OR gate. We are designing the full adder. Now, simply half subtractor. Half subtractor means 0, 0, borrow 0, difference 0, 0, 1. When we are subtracting 1 from the 0, definitely there will be 1 borrow, the difference will be 1. 1, 0, borrow is 0, difference is 1. 1, 1, borrow is 0, difference is 0. From this you can say the borrow is given by A bar B. Borrow is given by A bar B, and again the D difference is A exclusive OR with B. A exclusive OR with B. That is equivalent to what? Sum. Means this is the half subtractor, A exclusive OR with B, and this is the A bar B. This is a half subtractor. Very simple circuit. So there may be 1 mark question on this. Then similarly for full subtractor, right? For full subtractor, the difference will remain same. For example, when we are subtracting, the difference is equal to, just like similar to what? When we are saying that previous borrow, we are this is the number 1, 2, 4, 7. 1, 2, 4, 7. That is the number. And then what about the borrow? So remember this. This is 0, 0. This is the borrow is 1, difference is 1. Borrow is 1, difference is 1. Then 0, 1, 1. When we are subtracting 0, there will be the borrow. And then when we are subtracting 1, 1 minus 1, that is you are going to get the 0. That is the difference, 1, 2, 4, 7. And then 1, 0, 0, 0. 1 minus 1, 0, 0. And that is 0. And the difference is what? This is borrow is 1 and difference is also 1. Right. Now that is the number 1, 2, 4 and what? 7. Then the difference is given by 1, 2, 4 and what? 7. Remember this number, okay? Because we have to design the decoder by, full subtractor by using decoder. It will help you. Second, what is the borrow then? Borrow out. This is the function of the 3-bit and that is given by, first of all, 1, 2, 3 and what? 7. 1, 2, 3 and 7. That is the number. Okay guys, I think that is clear to you. Okay. Then 1, 2, what is the 1? Praveen, you are asking what is the 1 minus 1 difference is 0. Yes. 1 minus 1 is difference is what? 0. When we are saying that full subtractor means we are subtracting, for example, A. We are subtracting A minus B minus C. Actually, we are subtracting like this. A minus B minus C. For example, in last case, 1 minus 1 minus 1. 1 minus 1 minus 1. So, what is the 1 minus 1? 0. 0 minus 1. 0 minus 1 is difference is 1, borrow is 1. 0 minus 1 means difference is 1, borrow is 1. So, that is the concept. So, A minus B minus C. To subtract this, 1 minus 1 minus 0. 1 minus 1 minus 0 means what is this? 0. 0 minus 0, that is 0. There is no borrow, no difference. 0, 0. Right? 1, 0, 1. 1 minus 0 minus 1. So, that will become difference is 0, borrow is 0. I think now it is clear, everyone. Now it is clear. Okay. So, that is the number. Okay, Praveen. So, remember this number 1, 2, 4, 7 and 1, 2, 3, 7. 1, 2, 4, 7 and 1, 2, 3, 7. This is important. And for some, these numbers are important. 1, 2, 4, 7 and 3, 5, 6, 7. Then you can also design full subtractor by using what? 2 half subtractor and 1 extra OR gate. Now you can design it. Okay, then most important one is what? The ripple carry adder. Ripple carry adder means, suppose we want to add 4-bit, right? For example, you want to add 4-bit like A3, A2, A1, A0, B3, B2, B1, B0. Now you want to add this to number and then there may be a carry or it may be 0. There is a previous carry C0. Then A0, B0, C0, it will give the sum S0 carry C1. A1, B1, C1, it will give the sum S1 carry C2. A2, B2, C2, it will give you the sum S2 carry C3. A3, B3, C3 will give you the sum S3 and carry what? C4. For addition of 4-bit, 4 full adder is required. But remember, here A0, B0, C0, A1, A2, A3, B3, B2, B1, these all are available at t equal to 0. This is available, this is available, this is available, this all are available and this is also available. But C1, C2 and C3, these are not available. Okay, so therefore the first full adder, this one is the lowest full adder. Here C0 is available, A0 is available, B0 is available, but for this full adder it will wait for C1. This full adder will wait for C2, and this full adder will wait for what? C3, and that's why it is called ripple carry adder. Ripple carry adder. Now in that case we have to find the propagation delay. Okay, propagation delay, and what is the worst time taken by the circuit to complete its process. Okay, so what is the delay? This type of questions they may ask. Okay, what you want, they see Raghuram, if it is a negative number, borrow will be 1 MSB bit. When we are not dealing with the 2's complement number. I will give you the idea about that, how we can add or subtract the 2's complement, then what will be the result. Okay, okay, no problem. Then that is the ripple carry adder. There is a delay because of this propagation of this carry, right? C1, C2, C3 and C4. Now on this diagram all are full adder. Okay, this is full adder. Now remember one thing, we can design the full adder by using 2 half adder or 1 OR gate, or directly we can design the full adder by implementation, that is called 2-level implementation, that is called SOP form, SOP, sum of product form we can implement. Now we are having the different types of question. With the questions you will get the idea. So I am going to solve 4 to 5 questions on this diagram. Okay, one by one. Then first, what is the ripple carry adder advantage? There may be MSQ on that, multiple select question this time. So there is a propagation delay of the carry. So why we are using advantage? Simple and easy to design. But what is the disadvantage? Slow adder. Why it is a slow adder? Because delay due to propagation of carry. That will be the question. So it is MSQ. Now this is this type of question. Everyone please try to give me the answer for this question. Okay, okay, then a 4-bit ripple carry adder is realized using 4 identical full adder. 4 identical full adder. The carry delay of each full adder is 15 nanosecond. Carry delay. So we are representing it by the delay due to carry or carry delay. You can show like this, tau C. Tau means delay and C for carry delay. It is given as 15 nanosecond. And the sum propagation delay. Sum propagation delay. Like this is represented by tau S. S for sum of each full adder is 25 nanosecond. Now my dear students, tell me, what about the internal diagram of full adder? The internal diagram of full adder is not given. It is simply given what is the carry propagation and what is the sum propagation. If the internal diagram is not given, and how many 4-bit ripple carry adder, then what is the worst case delay for this full adder? Worst case delay means simply it is a full adder. We have no idea about the internal diagram. This is the carry input, that is the carry output. This is the sum output, A and B. These are the inputs. This is the standard diagram. Here we are giving A0, B0, A1, B1, A2, B2, A3, B3. Here we are getting S0, S1, S2, S3, and that is what? C4. When we are getting the complete result, that is the C4 is available, S3 is available, everything is available, then what will be the delay? So in that case, directly you can use the shortcut n-1 delay, total propagation delay, or simply what? Question the worst case delay. Delay is given by n-1. N is the number of bit, that is the carry propagation delay, plus maximum of, और जो भी higher है, higher from tau C or tau S. Tau C or tau S, where tau C is what? The propagation delay of carry, and tau S is what? Propagation delay of sum. Then what is the result here? So how many number of students have given the 70 nanosecond? One student have given the 85 nanosecond. One is given as 60 nanosecond. So according to this formula, n-1, so how many bit? 4 bit. 4 minus 1 tau c. What is the propagation delay? 15 nanosecond. Plus maximum of this, so sum or carry, which one is the maximum? Sum is maximum, 25. So it will become 45 plus 25. And what is the 45 plus 25? That is nothing but 70. 70 nanosecond is the answer for this question. Okay, directly you can use. For example, in this question, if carry propagation delay is 15 nanosecond, but the sum propagation delay is 10 nanosecond, this is given, then it will become 4 minus 1 into carry propagation delay plus maximum of these two. Which one is the maximum? 15 nanosecond, or higher of these two, 15. Then 45, 3 into 45 plus 15. In that case, it will become what? 60. In that case, it will become 60. Now, I want to ask one question. How many students given the answer 45 plus 25 is equal to 60? How many students? This type of silly mistakes. This type of silly mistakes. 45 plus 25, that is equal to what? 60. So what about one student have given the answer? Raghuram, this was the mistake. This was the mistake. Tell me. So that is, if you are doing this type of mistake, then it is called what? Silly mistake. Okay, remember that. Okay then, so that is the answer for this question. Now tell me, what is the answer for this one? So similar type of question in GATE 2014 2 marks question. 16-bit triple carry adder is realized using 16 identical full adders. No, we can increase the number up to 16 or up to what, 20 or 30 or 40. It may be given, but here 16 identical full adder. Again, internal diagram is not given. As shown in the figure, the carry propagation delay of each full adder is 12 nanosecond and the sum propagation delay is 15 nanosecond. Again, sum propagation delay is high. Very simple. You can use the same formula. Carry propagation delay is 12 nanosecond. Sum propagation delay is 15 nanosecond. It is given in the question. Worst case delay, it is asked. Very simple. Then use the same formula, n minus 1 into tau c plus tau s. Why? Because it is higher. 16 minus 1 into 12 plus 15. 15 into 12 plus 15. 195 nanosecond. 195 nanosecond. That is the answer for this question. Okay. So already we have solved two questions on the basis of this. Right. So these are the two typical questions on ripple carry adder. Now different types of question. Different question on this same diagram. Okay. Consider a 8-bit. Now they will change the language of the question. Concept is similar, everything is same, but they can change the language. Consider an 8-bit ripple adder in which, I think this is clear to you everyone. This formula is clear. This is standard formula is clear. Now next one. Consider an 8-bit ripple in which each full adder takes 15 nanosecond to generate the carry and 20 nanosecond to generate the sum. Again, what is the carry delay? 15 nanosecond. Sum delay 20 nanosecond. Again, sum is high. To generate the sum, what is the maximum rate of addition which can be obtained using this adder? What is the maximum rate of addition? Means addition per unit time, addition per second. We have to find addition per second. Then what is the answer? In that case, what is the maximum rate of addition per second? Then first of all, what is the delay for one addition? Complete one addition. What is the total delay? So delay, that is time taken for one addition, is given by, it is a 8-bit ripple adder. 8 minus 1 into carry propagation delay 15 plus maximum of this two, 15 and 20. Which one is the maximum? 20 is the maximum. 20. Then 18 minus 1, 7 into 5, 105 plus 20, that is become 125. What is the unit? Nanosecond. 125 nanosecond is the total delay for one addition. Now what is the rate? Maximum rate of addition means reciprocal of this. Rate of addition means in 1 second how many addition? So 1 divided by 125 into 10 raised to power minus 9, that is the nanosecond. It will become 10 to the power 1000 into 10 to the power 6 divided by 125 divided by 125, and you will get the answer for this question. Okay, so that is the 10 to the power 8 into 10 to the power 6. Okay, 8 into 10 to the power 6 addition per second. This is the capacity. Okay, then watch, what about the delay? We are doing 8 into 10 to the power 6 addition per second, right? That is the rate to this type of questions. Okay, you are saying that sir, it is a frequency megahertz and so on. Yes, number of, we are saying when number of cycles means when we are doing the addition, number of addition per unit time. So that is the answer. So simply change in the language, for find the delay, get the reciprocal of the delay, you will get the rate of addition, right? Next one, next question on this same concept, right? Now here internal diagram is given, internal diagram of the adder is given. Remember, this topic is very important. We are going to solve 5 to 6 questions based on this topic, that is on ripple carry adder, so that you will get the idea. Okay, and in GATE exam definitely they are going to ask. Consider a 4-bit ripple carry adder. Okay, each full adder is implemented using a 3-input XOR gate, 3 2-input AND gate, and a 1 3-input OR gate. Each full adder, 3 2-input AND gate and 1 3-input OR gate. Consider the delay of 3-input XOR gate to be 3 nanosecond, and the delay of each 2-input AND gate 1 nanosecond, and delay of each 3-input OR gate to be 1 nanosecond. Right? The total time taken by 4-bit ripple carry adder to perform the successful addition operation is. Now my dear friend, to understand the language of this question, remember one thing, what is the sum? Suppose I am taking the ABC as a bit. So what is the sum? Already I have given. ABC is equal to 1, 2, 4, 7. When we are solving this, you are going to get the A exclusive or with B exclusive or with what? C. C is the previous carry and A and B are the bits. That is the simple. Okay, 3 input XOR gate. Second, what about the carry? Carry already I have given 3, 5, 6, 7. It is the majority gate. When we are solving by using the K-map, already Rakesh sir have given you the idea about the K-map. So with the help of K-map, we can solve this 3, 5, 6, 7, minimize it. When we are minimizing, you are going to get the AB. This is a standard answer, BC plus what? CA. AB plus BC plus CA. Now you can design a full adder by using one XOR gate, 1, 2, 3, and here we are using 3 AND gate and 1 OR gate, 3 input OR gate, and this is the 2 input AND gate. Here we are giving the AB, BC, CA, and then finally here you are going to get the carry. This is the carry out and this is the sum out. Here we are giving the A, B, C, and C is the carry, previous carry in. Okay, so that is called full adder. Now this time the diagram is given. So tell me, what is the delay of this gate? In question, delay of XOR is given. Delay of XOR is given as 3 nanosecond. Consider the delay of 3 input XOR is 3 nanosecond. The delay of each 2 input AND gate be 1 nanosecond and delay of each 3 input OR gate be 1 nanosecond. Delay of this is 1 nanosecond. Delay of this is 1 nanosecond. So what is the total delay? Carry delay is 2 nanosecond. Sum delay is 3 nanosecond. You got the carry delay and what? Sum delay. Okay. Once you will got the carry delay and sum delay, 2 nanosecond and 3 nanosecond. Now, consider a 4-bit triple carry adder. So we have the general formula n minus 1 tau c plus maximum of tau s. 4 minus 1 into tau c, already we have to calculate. That is what is the value here? Yes, 1 plus 1, 2 plus maximum of 2 or 3 is what? 3. 6 plus 3, that is 9 second. 9 nanosecond. 9 nanosecond. So new students, third year students, remember, if you are not having this idea about that, this is a standard circuit. We have 1, 2, 4, 7, and what is the standard for this? A exclusive or with B exclusive or with C. And when we are minimizing the, that is carry, that is the 3, 5, 6, 7, you are going to get the AB plus BC plus CA. No doubt, in exam hall you will be able to solve this question, but it will take around what? 5 to 10 minutes. But we have limited time, and that's why remember the standard answer. Remember the standard answer for adder, full adder, half adder, full subtractor, and what? Half subtractor. Okay. So these are the standard circuit. 9 nanosecond is the answer for this question. Then next one. I think this question is clear to you. This is another type of question. Now next type on the same. Now this time, this is a very, very important one. Everyone try to solve this question. Half adder, remember, half adder is implemented with XOR and AND gate. Diagram is not given. Half adder is implemented using the XOR and AND gate. Full adder is implemented with 2 half adder and 1 OR gate. This is a standard circuit. So what is the standard circuit for half adder? This is the half adder. It is internally connected. It is another half adder, 2 half adder. This is internally connected. 2 half adder with the help of 2 half adder and 1 OR gate. This is the OR gate. This is connected here. This is A, B and C. This is connected here. Now this output and this output is connected here, and that is called the carry plus 1, or this is called sum. This is the AI, BI and what? CI. So this is the full adder by using the 2 half adder and what? Carry. Diagram is not given in the question. You have to draw the diagram here. Okay. Once. Now that this is a full adder, so half adder is implemented. This part is over. The propagation delay of AND and OR gate is 1.2 microsecond. For AND gate 1.2 microsecond. For this gate 1.2 microsecond. For this gate 1.2 microsecond. And a 4-bit triple carry binary adder is implemented by using 4 full adders. The total propagation delay time of this 4-bit binary adder in microsecond. And XOR gate ka kya diya hua hai? What is the XOR gate? The propagation delay of XOR gate is twice that of an AND and OR gate. So what is this delay? 1.2, 1.2, 1.2. So what is the delay for this? What is the delay for this? Double. 2.4. 2.4 and 2.4. Now, there are 2 methods to solve this question. Okay, 2 simple. So what is the? Some student will directly solve it and they will give the answer. For example, they will give the answer like this. What is the delay in the sum? 2.4 to plus 2.4. The sum delay is 4.8. This is the 2.4. This is the 2.4. So what is the delay in the sum? 4.8. What is the delay in the carry? For example, what is the path here? AI, BI, this is the AI, BI. Now this is connected here. So up to this point it is available at 2.4. Okay. Now this is available at 1.2. So this is available at 1.2, but it will wait for the next signal. 2.4 plus 1.2, it will become 3.6. 3.6, after 3.6 it is available here. After 3.6 it is available because it is available at 0. 2.4 and 0, it will wait for this. So 2.4 plus 1.2, that is the 3.6. 3.6 plus 1.2, it is also available at 4.8. Now, the some student will solve directly by using this formula. N minus 1 tau c plus what? Tau s. 4 minus 1 into, try to understand, 4 minus 1 into tau c. What is the tau c? 4.8. Plus maximum of this, maximum. So both are equal, 4.8, 4.8, both are equal. Tau s or tau d, tau c. Which one is higher? So 4.8. Now this will become 3 into 4.8 plus 4.8. Now calculate, but is it right? Is it right or wrong? You will get the answer 19.2. Okay, 19.2. But remember, if it is full adder is given, I am giving you the different approach. Already in GATE exam one question. So 19.2 you are getting the answer for this particular question. Okay. Now once we have the internal diagram, then what will happen? Watch this diagram. This is the full adder. Now I am changing the position. I am having the 4 full adder here. First, second, third and fourth full adder here. Now everyone please focus on the board. Watch this diagram. Right. This is the half adder. Everyone, this is visible to you? Okay, this line is visible to you. Divide this diagram into 2 parts. Right. Now, these values, for example, we want to add A naught, B naught, and this is the C naught. Then A1, B1. It will wait for the C1. Here we are getting the C1. That is the carry. Here we are going to get the carry. Here we will get the sum S naught. Now, this carry is attached here. This carry is attached here. Okay. Then A2, B2 is available here. This will wait for C2. So where is the C2? This is the C2 is available here. Now C2 is connected here. Okay. Then A3, B3. It will wait for what? C3. C3 is here. Now it is connected here. And finally, here we are getting the S0. This is the S1. This is the S2. This is S3. And finally, we are going to get the C4. C4. The process will complete here. Okay. That is the diagram. Okay, guys. So this is the actual internal diagram when we are connecting it. So actual, what will be the actual delay here? Then, for example, what is the delay for the XOR gate? 2.4. What is the delay for OR gate, AND gate? 1.2. So this A0, B0, C0, A1, B1, A2, B2, A3, B3, these are available at t equal to 0. So which quantities are available at the t equal to 0? A3 available, A2 available, A1 available, A0 available, B3 available, B2 available, B1 available, B0 available and C0 is available. These all are available at t equal to 0. Now the procedure will start. So procedure will start. So at this point, signal is available, exclusive OR, at this point it is available at 2.4, at this point it is available at 1.2. This is available at t equal to 0. I am writing just 0, 0, 0. This signal is available at 2.4, this is available at 1.2. This is available. Now try to understand. I will give the point here. This is available at 0, this is available at 0, 2.4, 1.2. 2.4, 1.2. Try to understand this concept. 2.4, 1.2, these are the available. Okay. Now, what will happen? Once it is available here, 2.4 plus 2.4. This sum is available at 4.8 nanosecond. 4.8 nanosecond. You have to add the delay of this gate only. 2.4, 2.4. Because this second signal is available at 0. Second signal at this point, this C0 is available at 0. That's why we have to consider the more delay. That is the 2.4 plus delay of this 2.4. It will become 4.8. Now, try to understand the delay of this gate. Delay of this gate is 1.2. Now, one signal is available at 0. Another signal is available at 2.4. And that's why this signal is available at 3.6. 3.6. And this is available at 0. So, 3.6 plus 1.2. This C1 is available at what? 4.8. This C1 is available at 4.8 nanosecond. If it is available at 4.8 nanosecond, now it will wait for this to 4.8. This is 4.8 here. Now this is 1.2, 2.4. Once it is available at 4.8, this point is connected here. 4.8, this is available at 2.4. Choose higher one, 4.8 plus 2.4. This sum is available at 7.2. What about this carry? 4.8 is available here. This is the 4.8. It will wait for this. Plus 1.2. This is the 4.8. Once it is available, plus 1.2. This will become 5.6.0. 6. Okay. This is available at 6. Now what about the another signal? This is available at 1.2. So higher plus the delay of this 7.2. This is also available at 7.2. Now watch this. This is 7.2. Now this signal is available at 7.2. This is available at 2.4. You have to add the 2.4 here. Then this will become 8.6. This is available 7.2. Add 1.2. 7.2 plus 7.2 plus 1.2. 1 minute. This is the 9.6. Sorry. 9.6. 7.2 plus 1.2. It will become 8.4. 8.4. At this point, now we have to add this delay. Why we are adding? Because at 7.2, this gate will wait. 7.2 plus 2.4, it will become 9.6. Here it is 7.2 plus 1.2, it will become 8.4. Again, it is available at 9.6. Now you have to add the delay of this gate and this gate continuously. Now 8.4. At 8.4, it is available, my dear student. Now this is available at 8.4 plus delay of this 2.4, and then you have to add the 8.4 plus delay of this gate and that gate. What will be the total delay? Now you can find the value for this question. 9.6, no? 9.6, not 8.4, 9.6 here. 9.6 here. 9.6. 9.6, this carry is available. Now 9.6 plus 2.4, it will become what? 12. And 9.6 plus 1.2 plus 1.2, it will become 12. So what is the total delay? 12 nanosecond. 12 nanosecond is the delay for this question. I think this concept is clear. Okay. Bharat, congratulations. So you are now selected for what? Okay, BARC exam. Okay. So that will give the motivate to all other students. Congratulations, everyone. Please give the wish him, right? And other students, simply focus on the subject. It is a Maha Marathon session last year. First ranker, right? Got the idea from this Maha Marathon. So it is a quick revision of all the subjects, right? All important topics. Definitely you are going to enjoy the session. You will get the concept, you will get the idea about the basics, you will get the idea about all the important topics also. Okay then. And Hemant Krishna, what is the difference between this idea and that one? My dear, in this case, if the internal diagram is not given, only the full adder circuit is given, right? Then we have to use this formula. Suppose this is given, right? This is given. Internal diagram is not given. So what will happen? We have no idea about this. So we will wait for the carry. And that's why this is the sum. In this case, we are using this formula. What is the total delay? And that's why we are getting the 19.2 nanosecond. But tell me, in this question, all the internal diagram is given. Half adder is implemented with the X and OR gate, a full adder is implemented with the 2 order, and all the internal diagram is given. If the internal diagram is given, then if suppose I am unboxing this, that is the internal diagram. I am giving the connection here. This C1 is connected to this carry input for that one, and so on. When we are solving, tell me what is the worst case delay, my dear? Malati, now it is clear? Hemant, now it is clear? So this is the case. So what is the delay here? Only 12 nanosecond, or in this case we are getting the delay what? 19.2 nanosecond. So which one is the worst condition? 12 nanosecond or 19.2? So definitely the answer is what? 12 nanosecond. 12 nanoseconds. Okay. I think now it is clear. Okay. By using the half adder. Now remember, this diagram is very, very important. In exam hall, we have to solve like this. Okay. Draw the diagram 1, 2, 3, 4, neat and clean diagram on your scribble pad, or once we are giving the 2 diagrams, with the help of 2 diagrams you will get the idea. For example, here it is a 4.8. Once you will get the idea of 4.8, you have to add only the delay of these 2 gates. Now once you will get the 4.8 plus 1.2, 1.2, 2.4, you will get the 7.2, 7.2 plus 2.4 plus 2.4. In this way we will get the idea. So what is the shortcut for this? Once you will find the value 4.8 for C1, 4.8. Then for C2, it will become 4.8 plus 2.4, 7.2. For C3, it will become 4.8 plus what? 7.2 plus 4.8. 4.8 plus 2.4 plus 2.4, that is nothing but 7.2 plus this, and you will get 9.6. And then finally for C4, 9.6 plus 2.4, you will get the 12 nanosecond. Similarly, you have to find the for sum. What is the delay for the S0? That is the 4.8. But this sum will wait for the carry. Where is the carry? At this point. To get the sum, 4.8 plus 2.4 for S1. 4.8 plus 2.4, you will get the sum at 9, that is what? 7.2. Okay. Then what is the S2? No, you have to carry plus 2.4. What is the delay of the carry here? What's the carry? 7.2. So 7.2 plus extra time is required, 2.4. Always this is the carry. This is the delay of the carry. Then you will get the 9.6. Here's S3. To get the S3, 9.6 plus 2.4. 2.4, for example, and you are going to get the 12 nanosecond. That is the total delay. Okay. I think this concept is clear to you. This is clear to you. So this is a very, very important. These are the right. So ये आएगा. Yes. You can verify it, Aditya. Now you can verify. Already I have given. Right. Already I have given the delay. Now you can verify it. Okay. Because we have to add, because they will change. Try to understand. They will change the delay of what OR gate, or they may change the delay of what AND gate, or they may change the delay of what XOR gate. Right. So always remember, they may change the delay of this or that. So once we may write the shortcuts and so on. Already I have given you the shortcuts and so on. Now next one. Next diagram. Right. Because okay, Aditya, shortcut will not work because once they will give what value of some data is given. In a previous question, one data is given like this. Try to understand. Data is given like this is 0, 0, 0, carry, initial carry is 0, then this is the 1, 0, right, up 1, 0, 0, 1, 1, 1. This data is given. And according to that data, what is the delay you have to calculate? According to the given data, you have to calculate the delay to add these two numbers. This type of question they may ask. Okay, next one. Now, because there is a delay in ripple carry adder, so what is the solution? Look ahead carry, right? A look ahead adder reduces the propagation delay by introducing more complex hardware. What about the ripple carry adder? Very simple circuit, but look ahead carry adder is a very complex circuit, but it will reduce the delay. Now, how? This is the internal diagram of, this is the complete diagram of look ahead carry logic. Here we are getting the sum, it will generate the carry. This is the half adder. Here we are generating, this is called carry propagation, AI, BI. When I am writing the AI, this is BI, this is the previous carry CI. Here I am getting the next carry CI plus 1. Here it is called carry AI exclusive or with BI. This is called carry propagation. AI exclusive or with BI. And this is called carry generation. AI, BI. Okay. Then, what is the internal diagram? This is the carry generate signal. This is the carry propagate signal. And that is the CI plus 1 is given by PI CI plus GI. PI CI plus GI, because here we are going to get the PI, this is the previous carry CI, and that is here we are getting the GI, you will get PI CI plus GI. What will be the question on look ahead carry adder? How we are going to get the idea about that? So very simple, simple carry, right? Directly you will get the idea, standard formula. Then that is the arrangement. It is a theoretical question because it is a standard circuit. Remember one thing, we have to generate the P3, G3, P2, G2, P1, G1, P0, G0, right? And it is a carry propagation. Again, we have to apply what one exclusive OR gate. Always remember, inside the carry, there will be the two-level implementation. There will be the two-level implementation, AND gate and OR gate, right? This is the two-level implementation, this is the one level, and this is the another level. So there are four level, 1, 2, 3 and 4. Okay, and the delay of each gate will be provided in the question. Then you have to find the total delay. Or second type of questions, how many number of AND gate and OR gate is required. So this type of questions from look ahead carry adder. Now this is the internal diagram. Always remember, because it is a theoretical question and we can't design it here, then always remember, for example, if I want to generate carry C1, right, carry C1 or C2 or C3 or C4, suppose I want to add this number A3, A2, A1, A0, B3, B2, B1, B0. C0 is available initially, then you have to generate the sum, you have to generate the carry C1, first of all carry C1, then here you will get the S1 carry C2, here you will get the S2 carry C3, here you will get the S3 and finally carry C4. You have to generate the carry C4. To generate carry C1, how many number of AND gate is required and how many number of OR gate is required? Always remember, if it is 1 is given, 1, C1, C0 is the first carry, it is already available here. C1 means one AND gate is required, one OR gate is required. Watch this diagram. To generate the C1, one AND gate is required inside the look ahead carry adder and one OR gate is required. To generate the carry C2, two AND gate is required, one OR gate is required. Watch this. To generate the C2, 1, 2, two AND gate is required, one OR gate is required. Then to generate C3, this is the 3. 3 means 3 AND gate is required, 1 OR gate is required. For example, this is the 1, 2, 3, and this is one OR gate, right? Similarly for C4, for example, we have to generate the C4 carry. So 4 AND gate is required, 1 OR gate is required. So suppose I want to design a look ahead carry adder for 4 bit, this is a 4-bit look ahead carry adder. Then how many total number of AND gate inside the look ahead carry adder? This may be the question. Add these two numbers, 2 plus 1, 3, 3, 3, 6, and total 10 AND gates and 4 OR gate is required. That will be the question. That will be the question on look ahead carry adder. It is a faster, right? So this is the total number of AND gate and total number of OR gate to design this circuit. Next one. Now this is the question, this type of question from Arey kya hua bhai? Please share the link of this session. Now guys, after this I will discuss what multiplexer, right? Now 4-bit carry look ahead adder which adds 2 4-bit number. It designed using AND or not NAND NOR gates only, right? XOR, we are not using the XOR gate. AND or not NAND NOR gates only. Assuming that all the inputs are available in both the complemented and uncomplemented forms and the delay of each gate is 1 time unit. What is the overall propagation delay of the adder? Assume that the carry network has been implemented using the 2-level AND OR logic. 2-level AND OR logic. So what is the total delay, my dear students? Total delay of this circuit. So total delay, to find the total delay for a look ahead carry adder, this is the diagram, and we are not going to use the XOR gate. We are not going to use the XOR gate. Only we are using AND gate, OR gate, NOT gate. This is given. NOT gate, NAND gate, NOR gate only. XOR gate is not given here. Okay. Then look ahead carry, again watch the standard diagram. In this standard diagram, here we are using the XOR gate. There are 4 levels, but it is XOR gate. Then inside this there are 2 levels. Already I have given AND gate and OR gate. There are 2 levels, and again there is a XOR gate, but this time XOR gate is not given. So how we are going to design the XOR gate? For example, this is the AB. A exclusive OR with B. This is nothing but A bar B plus AB bar. So again we have to make the 2-level implementation for XOR gate. This is the 2-level implementation for XOR gate. A and its complements both are available. That's why we can directly use this, and no need to use the NOT gate because complements are available. You will get the A exclusive OR with B. Means to implement these XOR gate, 2-level is required. To implement these XOR gate, 2-level is required, and inside these there are 2 levels. Combination of AND gate and OR gate. This is the case. 2-level implementation. So 2 plus 2 plus 2. So signal will propagate from this point to this point. The 2 plus 2 plus 2 is what? Total delay is what? 6 times. Total delay is 6 times. So what is the advantage of this? What is the advantage of this diagram? If suppose we are increasing the number of bits, for example, it is a 4-bit adder. Again, same time required 6 times. 8-bit adder. Again, same required 6 times. Right? It will not increase. It will not increase, my dear students. Okay. But in case of ripple carry adder, if number of bits are increases, the propagation delay will increase. So that is the advantage of this circuit. It is a faster one. So 2 for XOR gate, 2 for internal implementation, and 2 for this XOR gate, because we have to design the XOR gate like this. This is the 2-level implementation of XOR gate. So total 6 times. And so this type of two types of question from look ahead carry adder and theoretical question, it is a faster. More hardware is required. More hardware is required. Drawback of this circuit. Okay, next one. Next question, my dear friends. Now, what is the use of ripple carry adder, 4-bit ripple carry adder? Directly they will give you the question, what is the name of this circuit? The name of this circuit here watch this diagram carefully. Watch this diagram carefully. Here ABCD is given, any number is given. We are adding what? 0011. So this is the BCD code 8421. Or in 8421, when we are adding 3, 0011, what will be the result? If I am having the BCD, that is binary coded decimal 8421, and I am adding 3, then what will be the result? So that is nothing but this type of diagram they will give, and this is the binary code 8421 0000 0001 0010 0011 0100 0101 0110 0111 1000 1001. That is the BCD code. When we are adding this 3, you will get 5, 6, 7, 8, 9, code for 10, 11, and code for 12. What is this access 3 code? Access 3 code. So what is the answer here? Access 3 code. Hemant, if the XOR gate is available, they will give you the time, because always remember, normally for the delay for the XOR gate is greater than what delay for NOR gate or AND gate or what OR gate. They will provide you the delay. Here in this previous question, all the delays for NOT gate, NAND gate, NOR gate, these are given, and delay of each gate is 1 time unit, it is given. But always remember, from the previous question, what is the delay for XOR gate? 3 nanosecond, and what was the delay for AND gate and OR gate? 1 nanosecond. Again, in a previous question, what was the delay for AND and OR? 1.2 nanosecond, and for XOR gate just double, 2.4 nanosecond. So they will provide you the delay. Okay. Next question. So this is this type of diagram. Here we are giving the BCD, and here we are giving this is called 4-bit triple carry adder. The use of this. So this is access 3 code, converted into access 3 code. What are the properties of the access 3 code? Give me the answer. Now, comparator. Very quickly we will revise the comparator, then we will solve some questions on what? Multiplexer. So what is the comparator? Magnitude comparator, right? Magnitude comparator means we are giving the two numbers. It will compare whether A is greater than B, A less than B, or A equal to B. This is the use of the comparator. A means it may be of 2-digit number A1, A0. It may be of 3-digit number A2, A1, A0. It may be of 4-digit number A3, A2, A1, A0. Or similarly B. It may be 2-digit number. It may be 3-digit number. Or it may be 4-digit number. Right? So it may be 3-digit, 2-digit, 4-digit. So what will be the question? If suppose we are having 2-digit number, means 2-digit number means the value of n is what? 2. 2-bit number. 2-bit number. So what is the value here? 3. What is the number of n? 4 here. So they will provide you the number of bits, and they will ask for how many combination A is equal to B, for how many combination A is not equal to B, for how many combination A is greater than B, for how many combination A is less than B. So this type of questions, right? Yes, access 3 code is what? Self-complementary code. So this is the right answer, self-complementary code. And we are using the self-complementary code for subtraction. We are using the BCD addition, that is 8421 addition, but for subtraction we are using self-complementary code, remember that. Then design a 1-bit comparator. So no need to design here, directly they will I will give you the shortcut and directly use this formula. What is the condition so that A is greater than B or A is less than B? So these are the condition. Remember this one. Everyone tell me what is the answer for this one. What is the answer for this question? Then with this question I will give you the formula. For a 8-bit comparator, the number of combination for which binary number A is equal to B. A is equal to B. This is a 1-mark MCQ, multiple select question. For a 8-bit comparator, the number of combination for which binary number A is equal to B. So binary number A is equal to B means if it is a 8-bit, then n will become 8. For 2 to the power n times A is equal to B, right? Then total number of combination is 2 to the power, number of combination 2 to the power 2n. For 2 to the power n, A is equal to B. So for A is not equal to B, how many number of combination? 2 to the power 2n minus 2n, 2 to the power n. For this much number of combination, it is not equal. Then A greater than B or A less than B. How many combinations? 2 to the power 2n minus 2 to the power n divided by 2. 2 to the power 2n minus 2 to the power n divided by 2. So that is the most important question from what? Comparator. So what is asked? For which the binary number A is equal to B. So 2 to the power 8. What is the 2 to the power 8? 256. And tell me, for how much combination A is greater than B and for how much combination A is less than B. So to find the A is greater than B, 2 to the power 16 minus 2 to the power 8 divided by 2. For this much number of combination, A is greater than B or A is less than B. You can find. But remember, what is the 2 to the power 16? 6, 5, 5, 3, 6 minus 256 divided by 2. Divided by 2. Okay. So that will be the result for this particular question. This is the question. Okay. You can find this value. Yes. The next one. Next question. They will change the language. Please, in a case of digital, please try to avoid the silly mistakes. Right? Read question carefully. Yeah, digital we are getting the easy question, but sometimes we are making the mistake. If A and B are 4-bit binary number given to the 4-bit comparator, then the number of combination for which A is greater than B. If it is asked, then always use 2 to the power 2n minus 2n upon what? 2. That is nothing but 2 to the power 8. 4 into 2, that is 8, minus 2 to the power 4 divided by what? 256 minus 16 divided by 2. 240 divided by 2, that is 120. That is what? 120. That is the answer. C. 120. Very easy question. So again, from magnitude comparator, we are expecting this type of question. Okay. Now, next one is what? Very simple diagram. I have given the name here, binary to gray code converter, but they will give you the diagram and what is the name of this circuit. They will ask. So simply binary number, if it is given, you have to write the gray code. Gray code is also called reflected code. Gray code is also called cyclic code. 1 bit, right? Difference. What is the difference between the two consecutive codes? 1 bit difference, right? So 1 bit position difference. So binary to gray code converter, that is the diagram. Always remember, this is the binary to gray code. Okay. So that is the answer for this question. Okay. Then, are you getting this point? Everyone? B3, B2, B1, B0. This is directly we are writing G3. Exclusive or this will give you the G2. Exclusive or of this will give you the G1, and exclusive or of this will give you the G0. B3 exclusive or with B2, B2 exclusive or with B1, B1 exclusive or with B0. That is the case. G3, G2, G1 and G0. This is, and that is the result. Binary to gray. Direct question. Then gray to binary, always remember, gray to binary, right? G3, directly you will get the B3. Then if it is G2 is given, you have to make the exclusive OR of this two, and then you will get the B2. G1 is given, exclusive OR of this, you will get the B1. Then G0, exclusive OR of this, you are going to get the B0. B3, B2, B1 and B0. So this is what? Gray to binary. Gray to binary conversion. That is the diagram. You can watch this diagram carefully. They will give you the diagram. Directly you have to give the answer. Right. Then Now, one question on what read-only memory, ROM, read-only memory. This is again another combinational circuit. Okay, so this type of questions we can expect from the ROM, right? And read-only memory means what? It is a combination of AND gate and OR gate. We can't design AND gate, but we can design what? OR gate. So OR gate is programmable, but AND gate is non-programmable. It is a fixed AND array, programmable OR array. That is called ROM. Always remember, what is the ROM? They will ask. First of all, they make MSQ question on that. So always remember what is the ROM. ROM means fixed AND array, programmable OR array. Programmable OR array. Okay. Which type of diagram? Means like this is the ROM. This is given. For example, here 3-bit is given or 4-bit is given. Then it is actually a decoder. That this is a 3-bit X, Y, Z. So this is actually a decoder. Here we are having output of this decoder. Then here OR gate is connected here. And the connection with the OR gate like this. This is the OR gate. If you want to connect something, if you want to connect, for example, you want to connect this, then you can connect this, you can connect this, you can connect this. This is the function at F1, this is the function F2. You can connect. Now, from this you will get the this will be the question. This is actually a 3 to 8 line decoder. And this is the OR, this is nothing but complete design is what? ROM. Complete design is what? ROM. So everyone tell me, what is the function F1? What are the mean terms here? What are the mean terms here for ROM? What are the mean terms? So that if suppose this is the question, so this is a 3 to 8 line decoder. We will discuss more question on decoder, but that is the question. And this point is connected, this point is connected. So directly you can write F1. F1 is the function of X, Y, Z mean term. Which are the mean term? 0, 3, 6. Again, F2 is the function of X, Y, Z. 1 is connected, 3 is connected, 5 is connected, 7 is connected. 1, 3, 5, 7. 1, 3, 5 and what? 7. That is connected. So this is the function. With the help of K-map, we can minimize it and you will get the minimized Boolean expression for this one. Okay. So 1, 3, 5, 7. That will be the question. This is the by using the ROM. So similar type of question in GATE exam. Similar type of question in GATE exam. Okay. So what is the question here? Now it is given. Now I want to change one connection here. I am giving you the connection with the yellow line. This is connected here. D4. Okay. And then this is connected here. This is connected like this. Okay, tell me what is the answer? This is not connected and that is the case. Now this type of questions, if it is given, this what is written here? BCD to decimal decoder. BCD, binary coded decimal, means where we are going to give the 8421 code. 8421, it is given. 8421 BCD code is given, and when it is the register is connected here, if the current through the register will flow, then there will be the drop and output will be high. If there is no current through the register, there is no drop and this is connected to ground. Or when the current will flow, when we are giving, for example, I am giving the 0, 0, 0, 0. When I am giving the 0, 0, 0, this 0 is what highlighted, but it is not connected to any wire. And that's why all are the 0, 0, 0. All are 0, 0, 0. For example, I am giving 0, 0, 0, 1. it will decode and 1 will be high. It will be 0, 1 will be high. Wow, 1 is connected to last wire. Therefore, there will be the current, there will be the drop across the resistor. It will become high. 1 0 0 0 0. That is the case. 1 0 0 0. That will be the case. So what is the answer for this question? So that is the ROM. It is a gray code converter, 2421 BCD number, access 3 code converter, none of the above. Right? And that is the answer. My dear friends, always remember what we are getting actually, we can write a table here, right? 8421 code 0000, 0001, 0010, 0011, 0100, 0101, 0110, 0111, 1000, 100, that is 8, 1001, that is 9. These are the valid BCD number. 9. Now we have no idea about the result, but here the output is Y3, Y2, Y1, Y0. Y3, Y2, Y1, Y0. It is not connected to any gate. That's why we are getting the 0, 0, 0, 0. This is connected to first one, 1. This is connected to D2 is connected to 2, second one. D3 is connected to last 2. D4 is connected to 1 0 0. This is 0 1 0 0, 0 1 0 0, 0 1 0 0. It is up to what? 4. Up to 4. Now what about the 5 here? Now my dear, the standard 5 is what? 0 1 0 1. But what is here? Standard 5, D5, when we are giving the 0 1 0 1, 0 1 0 1, highlight is 5 is highlighted, but it is connected to what? First one and second last one. 1 0 1 0, 1 0 1 0. It will be 5. In which case 1 0 1 0. Write it 1 0 1 1. 1 0 1 1. Actually it is also connected here. Sorry. It is also connected here. Right. Now, if it is connected, then tell me in which case it will be 5. In which case it will be 5. 2 4 2 1 code. 2 plus 2 plus 1, that is what? 5. Right. That is the 5. Means what? What is the result here? Sound quality, picture quality, everything is fine now. Tell me, sound quality, everything is fine. I am going to cover what all the topics here. So please remember, each and everything is important here. Now after that we will discuss what multiplexer. No doubt you are waiting for the multiplexer. So simply it is a 2421 BCD numbers. You are going to get the 2421 BCD numbers. So complements, always remember it is a self-complementary code. If it is 4 is connected, for 5 this point is not connected, remaining point is connected here. For 3 the 6 is the complement. If the 3 is connected here, then for 6 these 2 are connected. For 2 what is the complement? 9's complement is 7. If 2 is connected here, then 7 is connected, remaining point, this point and that point, it is not connected here. Then for 8, if it is for 1, what is the complement? 8. This is connected here, these 3 are connected here. For 9, 0 is the 9's complement of 9, or 9 is the 9's complement of 0. So 0 is not connected to any wire, and that's why 9 is connected to all the wires. And that's why we are getting 1 1 1 1. 1 1 1 1 means what? Last point is 1 1 1 1. That is the complement. So how we are going to find this complement? 1 1 0 0. How we are going to find the complement? 1 1 0 1. Find the 1's complement, 1 1 1 0, and that is the result. This is called self-complementary code 2421. So answer for this question 2421 BCD numbers. So watch carefully, get the idea about the number system, and you will be able to get the answer 2421 code. Now time to start what? Some questions on decoder and then multiplexer. Finally, now first of all, what is decoder? This is the question on decoder, my dear friends. Decoder means normally we are using the binary decoder. For example, this is the 2 to 4 line decoder. 2 to 4 line decoder. 2 to 4 line decoder, always remember the output lines in case of decoder is less than or equal to 2 to the power n. Always output lines may be less than 2 to the power n, where n is the number of input lines. Number of input lines. Number of input lines. Now, very simple thing, very simple. No, it is not always, that is not the size of the decoder. Always remember one thing. If we are saying that the size of the decoder, or simply the decoder, n to 2 to the power n. No. Output lines may be 2 to the power n or less than 2 to the power n. Maybe, for example, in case of binary decoder, if we are giving the 4 lines, what will be the output line from 0 to 15? That is how many total lines? 2 to the power 4, that is total 16 output lines if we are giving. But if it is BCD decoder, we are giving the 4 lines W, X, Y, Z, but we are having total 10 output lines, 0 to 9. Only 10 output lines in case of BCD decoder. No doubt in case of binary decoder, we are having 2 to the power n lines. But here we are having the less than 2 to the power 4, means less than what, 2 to the power n lines. So what is the maximum output lines? That is the 2 to the power n. But it may be less than what? 2 to the power n. Remember one thing. Okay. Now, because that is in case of BCD decoder, we are having the 4 input lines but only 10 output lines. Then with the help of decoder, we can implement any function. For example, if I want to implement the half adder by using the decoder, so what is the half adder? In half adder, we are having, what is the half adder? Sum bit, A exclusive or with the B. What is the A exclusive or with the B? A bar B plus AB bar. A bar B is nothing but, this is nothing but D1. This is A B bar means what? D2. D1 and what? D2. 1 minute. D1 and D2. Okay. S. D1 and D2. Then what is the carry? Carry bit is what? Already we have the idea, AB. AB means what? D3. So simply you can implement the half adder by using the decoder. So D1 plus D2, you will get, you are going to get what? Sum. Directly D3, you are going to get the carry. So this is nothing but implementation of half adder by using decoder. Which type of questions they may ask? They will give you the circuit. What is the output? What is the output? It is a simple half adder circuit. That will be the question. Okay. Second type of question, second type, full adder circuit, for example. So remember one thing. What is the summation? It is the mean term. What are the mean term? 1, 2, 4, 7. Already I have given the idea about that. What is the carry? 3, 5, 6, 7. So directly with the help of OR gate, pass 1, 2, 4, 7. This is passed 1, 2, 4 and what? 7. You are going to get the sum. For carry out, connect D3, D5, D6 and D7. You are going to get the carry out. So with the help of 3 to 8 line decoder, we can design what? We can design full adder and we are going to get the sum as well as carry. This is the case. But we have to use external OR gate. External OR gate in case of decoder. Right. Ready to solve some question? Okay then. Now we will solve some numericals on this. First of all, what will be the function for this diagram? What will be the function for this diagram? This type of, very simple. Determine the output of the following logic circuit. Determine, right? It is a OR gate is connected. This D0 is connected. D2 is connected. D3 is connected. D6 is connected. D7 is connected. And what is the function? ABC, like this is the MSB. It will be given in the question, MSB. This is the LSB. If then the function will become ABC. What are the mean terms? This is the 3 variable. So what are the mean terms? 0, 2, 4. This is the connected here, 4. Then 6 and then 7. 0, 2, 4, 6, 7. Then minimize it by what? Boolean K-map. Minimize it by the Boolean K-map, you will get the minimized function. So this type of question from K-map. Now tell me what is the answer for this one, everyone. That is the question. Try to solve this question. Here the NOR gate is connected actually. NOR gate is connected. It is connected to output number 7. It is connected to output number 0. Nothing is given means definitely it will be what? It is not given here. Definitely it will be 6. What is this? 5. It is 0, then it is a 1. It is 2. So 7 is connected, 5 is connected, 2 is connected, 0 is connected, but it is a NOR gate. So what is the answer for this question? MCQ. A, B, C, or what? D. That is the question. This type of question from the decoder. And X, Y, Z is given. This is the MSB. Then remember, it is a NOR gate is connected, right? Be careful about the gate, whether it is a NAND gate is connected, NOR gate is connected, or OR gate is connected at the output. Please watch carefully. Then where that they will mention the MSB, watch carefully whether where the MSB is mentioned here. X is the MSB, Y is, and Z is the LSB, because we have to find the function in terms of what? X, Y, Z. Then it is connected to what? O7, O5, O1 and O0. Then you can write like this. Function will become, right? O7 I can write D7 plus what? D5 plus D2 plus D0 bar. This is the D7 plus D5 plus D2 plus D0 bar, right? And then you can write what is the function XYZ. XYZ plus XYZ, this is 5, plus XYZ, this is 2, bar, Y bar, Z bar, that is what? 0, the whole bar. Now with the help of Boolean function, Boolean algebra, you can find, you can take XZ as a common, it will become Y plus Y bar, right? And from this, right, X bar, Y bar you can take common, X bar, Z bar you can take common, it will become Y plus Y bar, this is X bar, Z bar common and complete bar, it will become what? XZ, because Y plus Y bar is equal to 1, X bar, Z bar, the whole bar. This is the NOR gate. Right, but it is a bar, and that's why it will become exclusive OR of Z. What is this? X bar Y plus X, X bar Z plus X Z bar. That is the answer. X Z bar, that will be the answer. Means first of all find the function, then you have to apply the Boolean algebra, or by using the K-map you have to minimize it. Then you are going to get the answer. So which answer is correct? X Z bar plus X bar Z. This is the correct answer. This is the correct answer for this particular question. Okay then. That is the answer. Now, next one. Next question. I think that is clear to you. This is also. Now, next one. If suppose bubbled gate is given. If suppose the bubbled gate is given, B is the correct one. For example, this is bubbled is connected. Bubbled is connected. Right? So, this bubbled is cancelled out with this bubbled. This bubble is cancelled out with this bubble. This bubble is cancelled out by this bubble. This bubble is cancelled out by this bubble. Means directly you can write what is the function here? D1 plus D3 plus D5 plus what? D6. That is the direct result here. D1 plus D3 plus D5 plus D6. Now with the help of K-map you can minimize it. It is a function of what? X, Y and Z, right? But remember one thing, when we are going to minimize it, what is the Z? You have to take the Z as MSB. Remember one thing, Z as MSB and X as what? LSB. Why? Because Z is connected to A2, Y is connected to A1, X is connected to A0. And that's why you have to take the Z as a MSB, Y, X as a LSB. So you have to write like this. And then find the numbers. And with the help of K-map, you can solve it. You can solve it, this number. Are you able to solve this number? Karthik, you are giving the 1356. Yes, 1356. But function is what? Z, Y, X. Z, Y, X function is. One, 3, 5, 6. Right. Then make proper K-map here. Here you have to write the Z bar, Z, Y bar, X bar, Y bar, X, Y, X, Y, X bar. 0, 1, 3, 2, 4, 5, 7, 6, because now it is a MSB, 0, 1. Then 1, 3, 5, 6, 1, 3, 5, 6, 1, 3, 5, 6. You have to minimize it, then make the pair of these two, then pair of these two, right? Y bar X plus what? Z bar X or X Z bar, Y bar cancel, and single one, that is Z Y X bar. That will be the result, right? So this is the result for this particular question. Okay, so be careful about the MSB. Be careful about the MSB. A2, A1, A0, that is connected here. Now next one, next question. This is a very conceptual question. Everyone try to give me the answer for this one. Try to give me the answer for this question. This is again a very important question. Find the number of mean terms in the function for the decoder circuit shown below. Find the number of mean terms. It is a decoder with inverted output. When the bubble is given here, it is a decoder with the inverted output. Inverted output means, suppose I am giving the 0, 0, 0 here. Then the 0 will become 0, remaining all will remain 1. Suppose I am giving the 0, 0, 1 here. Then 1 will become 0, all remaining, all the output will become what? 0, 1, 1, 1, 1, 1. Okay, that is called inverted decoder or decoder with inverted output. So decoder with inverted output. So what is the answer? Then find the number of mean terms in the function f, x, y, z for the decoder circuit shown in the figure. How many mean terms? Mean terms means, for example, in a previous question we are having the mean terms 1, 3, 5, 6. So in this case again we are having the mean terms. In a previous question we are having the mean terms 1, 3, 5, 6, 8, 1, 2, 3, 4 mean terms. So how many number of mean terms in this question? In this question. Okay. Now, you know, within 1 minute we can solve this question. Always remember, if the D0 is 0, these two will remain 1. If this is 0, then these two will remain 1. If this is 0, these two will remain 1, definitely. Because at a time, one output will be 0 and remaining output will be 1. So what is the beauty of the OR gate? If any one of the input is 1, the output will remain 1. What is the output of this OR gate? It is always 1. It is always 1. Now, for this NAND gate, this AND gate, D3 bar, D4 bar, D6 bar and D7 bar. Here you will get D3 bar into D3 bar, D4 bar, because we are getting the inverted output, D4 bar, D6 bar, D7 bar. Okay. Now it is multiplied with what? 1, or it is a NAND gate. It is what? NAND gate. So here you are going to get the 1 dot D3, D4, D6, D7. bar, the whole bar, bar, the whole bar. Then finally what will be the output? So finally the output will be D3, De Morgan's theorem, D4, D6, D7 bar. It will become what is the answer? D3 plus D4 plus D6 plus what? D7. So how many mean terms? 4 mean terms. 4 mean terms from this question. So 4 mean terms is the answer for this one. You are giving, some students are giving the 3 mean terms, some are giving the 4, some Neha 5. So how many? Tell me. So from this AND gate we are getting 1. From this 1, 2, 3, 4. This is become, and we are inverting it, 1 dot multiplied and bar, and according to De Morgan's theorem you are getting the 4 mean terms. I think that is clear to you. Okay, this is a good question. But 1 marks question directly we have to solve this. Similar type of question from the decoder. Now, normally in a decoder, enable pin is given. Normally in decoder, enable pin is given. So what is the use of the enable pin? I will give you the idea about that with the question. 1 minute. What is the use of the enable pin here? Yes. So that is one more important information for you guys. First of all, GATE 2023 General Aptitude 15 marks in just 15 hours coming soon by Rakesh Talreja. So please everyone join that session. Definitely you can secure your 15 marks within 15 hours. Complete General Aptitude by Rakesh sir. If you want the notification about this session, then simply subscribe our channel. Okay, you will get the idea about this session. Second one, mathematics. Nothing is impossible. So non-stop maths marathon, complete syllabus in 2 days by Rakesh Talreja sir and by what? Ankit sir. Okay, so total we can fix our 28 marks. 28 means 15 from aptitude and 13 from mathematics. So total 28 marks. Okay, so join this session on same YouTube channel, subscribe our channel. Okay then guys, so that is important information for you. Now what is the answer for this one? What is the answer for this question? Tell me. This is given in terms of max term, this is given in terms of mean term, and that is again given in terms of what? Max term. Similar type of question, but this time this is the MSB. This is the MSB. Okay, the Boolean expression ABC in the canonical form for the decoder circuit shown below is, this point is connected to the enable pin, right? Here the bubble is given. Bubble means it is a active low. It is what? Active low. When we are giving the C, we want 0 here. So when the C is 1, right, that is connected here. Because it is an active low, C is 1, it is inactive. When the C is 0, it will be active. C is 1 when it will be active. That is the meaning of this. This is the meaning of the bubble inverter. Okay, so active low device. Tell me, what will be the answer? Yes. Now, the Boolean expression ABC, it's in canonical form for the decoder circuit shown below. Okay, then again my dear students, one OR gate is connected here, but this time what is the problem? What about the device, whether it is enable or what? Disable, we have to find. Then accordingly we can find the function here. That NAND gate is connected here, AND gate is connected here, it is OR gate and NAND. Then for this particular case we have to write function here. We are having total 8 output. I am just writing 0, 1, 2, 3, 4, 5, 6 and 7. We are having the 3 inputs A, B, C. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. 101, 110 and 111. Right? Now this is 0, 1, 2, 3, 4, 5, 6 and 7. Directly when the C is 0, this device is enabled. When the C is 1, it will become, because it is the inverted output, it is given C is 1, it is disabled. So when the C is 1, you are going to get all the output is equal to what? 1. Because when it is disabled, you are getting the inverted output. All are 1. All are 1. No need to check because the device is disabled. All are 1. Okay, so that is the case. All are 1. Now when the C is 0, this device is enabled. Then tell me, 0 means 0. This is 0, all are 1. Because this time it is enabled. 2 is 1. 2 is 0, all are 1. Then 4 is 0, all are 1. Then from this 6, all are 1. Okay. Now watch this. What about the 1? 1 is always 1. Remember, 1 is always 1. If the 1 is always 1, D1 is always 1. If the input to any gate is always 1, input to OR gate is always 1. One of the input is always 1. So what is the output? 1. No need to check. No need to check 0, 1 or 2. Simply directly you can say output of this gate is 1. Now try to understand. What about the 3? 3 is always 1. So 3 is also 1. What about the 4? 4 is 0 here. Yes, there is a change in the 4. So we are writing the D4 here. D4 bar. Then 5 is not connected. Check the 6. 6, you have to consider the 6. 6 bar because it is 0. 7. 7 is always 1. When the 7 is always 1, finished, it will become D4 bar, D6 bar, dot 1, dot 1. D4 is 1, D7 is 1, 1. It is always 1. What will be the function here? Function will become 1 into D4 bar, D6 bar, 1 into 1 ka whole bar. Finally, you will get the answer D4 plus what? D6. D4 plus D6. That is the answer. So these are the mean term or max term. So these are the mean term 4 and 6. Max term is also given. Be careful. 4 and 6. That is the answer for this particular question. Okay, guys. I think that is clear. That is clear to you, right? Or now remember, my dear friends, if the C is 0 means odd term, if the C is 0 means what? Even term, or C is 1 means what? Odd term. C means it is a LSB. If the C is 1 means odd term. So all odd term are disabled. So all odd term are disabled means directly at the odd term you can write 1, 1, odd term 1, odd term 1. Directly you can write. Okay. But now in that case, no need to check the 0 and 2. No need to write the table also. 0 and 2, no need to check because one input is get this. You will get the 1. Second one, directly D4 is D5 is 1, D7 is 1. Okay, no problem. Now what about the D4 and what? This D3 is 1, D7 is 1, D4 and D6. Because these are the even number according to which we have to write the function. Directly you can write D4 bar into D6 bar. Then bar, directly you are going to get the answer D4 plus D6. No need to write this table also. No need to write this table also. Okay. That is the answer. Okay then. Next one. Next question on decoder. This one. This is again a very good question. Now give me the answer. This is PQ. This is P bar plus Q. Then this D naught is connected here. This is the D naught. D1 is not connected, D2 is connected here, D3 is not connected. This is the Y1, this is the I2 and I3, this is a LSB, this is the MSB, and D5 is connected here, D4, D5 is connected through this gate, D6 is not connected, D7 is connected, and this is the D4 actually. D4. And watch this, it is not inverted output, but it is an inverted output. Then what will be the answer for this particular question? This is the D0, D1, D2, D3, D4, this is D5, this is D6, this is D7. Okay, you have to solve this. Then please give me the answer in comments box. I will solve this. Answer is given, Y1 is the NAND of the P and Q, Y2 is the P bar, this is the P bar. This type of answer. Okay. If this is the Y1 is the NOR of the P and Q and Y2 is the P bar, NAND of the P and Q and Y2 is equal to P, NOR of the P and Q and Y2 is equal to what? P. So that is given. Okay. First of all, what is Y1? What is Y1? So when I want to solve the Y1, first of all, find in terms of what? I1 and I0. I1 and I0. So what is the Y1? This is connected here, D0. D0 plus D2 is connected here. D2. D0 plus D2. Y1. What is the D0? D0 we can write, because it is the MSB, I1 bar I0. I1 bar plus I0 plus D0. Both are bar, because D0 means 0. I1 bar, I0 bar. D2. I1, I0 bar. 1, 0. 1, 0 is D2. Now from this, you can take I0 bar as a common. When I am taking I0 bar as a common, it will become I1 bar plus I1. That is nothing but 1. So this is nothing but I0 bar. I0, what is connected to the I0? Through I0, PQ is connected. So it will become PQ bar. PQ bar. And this is nothing but what? NAND gate. This is the NAND of P and Q. So Y1 is NAND of P and Q. NAND of P and Q. Y1 is NAND of P and Q. Directly you can say. Now, to which answer is correct? Y1 is NAND of the P and Q. A is correct, or what? D is correct. C is correct out of these two. Now you have to find what? Y2 also. NAND. Okay. Now B and D is not the right answer. Then how to find the Y2 here? Y2. Then Y2 means this is the case where we can find the Y2. Y2 means D6 plus D7. Sorry, D5 bar. This is the D5 bar plus D7 को multiply. We have to multiply it. Why multiply? Because AND gate is used here and it is an inverted output to D5 bar, D7 bar. We can write D5 plus D7 the whole bar. Or what is the D5 then? We can write it like this. D5. When I want to write the D5, this is the second bit here. Always remember this is the second. So it can write 0, 1, 2, 3. It is a D5 means D5, sorry, D6 is connected here. Sorry, D6 is connected here. No problem. And प्रिंटिंग मिस्टेक के कारण थोड़ा सा गड़बड़ है. This is D4 is not connected, D5 is connected, D6 is not connected, D7. So already we have write D5 bar dot D7 bar. We can write bar. Okay. Then find right D5 means second one. Second one is what? This is the MSB. I3 bar I2 plus D7 I3 I2 1 1 1 1 means last one. From this you can take the I2 as a common, it will become I2. So what is the I2 connected here? You can find the P here. You can find the P bar. P bar here. So because bar is connected here. So what is the answer here? This one. A is the correct answer for this question. So in this way we can solve. In every question we have to apply what? Boolean algebra. We have to apply what? Boolean algebra. So directly you can solve, find the values, but always remember what about the inverted output and so on. I think now this is about questions. Second type of question in decoder, they will ask number of 2x4 decoder required to implement a 3x8 decoder. That will be the question. So how many numbers? Everyone tell me. Suppose I want to design 3x8 decoder by using only 2x4 decoder. No external gate, no extra hardware, only 2x4 decoder. Then always remember what is the output line here? This is the output line of required. What is the output line here? This is the output line for a given n for m. Okay. Then very simple method, 8 divided by 4, output line of required divided by given, you will get 2. This again divided by 4. If you are going to get the 0.5, it is not a less than 1, then always take one complete integer. 2 plus 1. How many decoder is required? 3 decoder is required. 3 decoder is required to design 3x8 decoder by using 2x4 decoder. Very simple circuit. Okay. So here you have to choose the 2 decoder. Here we are choosing 1 decoder. This is the 2 line 0 1 2 3. These are the 2 line. These are the 2 line 0 1 2 3 0 1 2 3. Here we are writing 0 1 2 3 4 5 6 7 as output. Here we are giving the MSB, LSBs, YZ, YZ. Now, if we are having the 3 input X, if you want to connect the X here, always remember, let this is the 0, this is the 1. YZ, okay? So YZ when I am connecting 1, 0, 1, 0, 1, 0. This is the MSB, this is the LSB. Suppose I am connecting X here, this should be connected toward ground. Then when I am taking the X is equal to what? 0. So 0, 0 means this will be enable. And this is connected to enable pin. Or when I am giving X is equal to 1, 1, 0 means 2. 2 is connected here. So this is how many required? 3. 2x4 decoder is required to design this. Very simple circuit. Then similarly, 3x8 decoder, it is over. Now, how many 3 to 8 line decoder with an enabled input are needed to construct a 6 to 64 line decoder? Everyone please give me the answer for this question, last one on this topic, then we will start multiplexers. 64. Output line is 64. What is the output line here? 8. 64 is divided by 8. It will become 8. Again 8 is divided by 8. It will become 1. Right. Already we are getting the integer 1. No need to divide it. 8 plus 1. How many decoder is required? 9. 9 is required to design 6 to 64 line by using 3 to 8 line decoder. That is the simple concept here. 9. Yes, you are giving the right answer. 9 decoder is required. Okay, so these are the questions on decoder. Now my dear friends, finally multiplexer. Finally the multiplexer. As you know, multiple input, single output. That is called what? Multiplexer. And it has 2 to the power n input lines, where n is the select lines and one output line only. One output line only. So selection line, that is the diagram. Here is the selection line is given S0, F, I0 and I1. Everyone please remember this formula. For 2x1 marks, when we are selecting, when the S0 is 0, it will select I0. and when the S0 is 1, it will select what? I1. And that is the formula for the multiplexer. That is the output of the multiplexer. Okay. So this is a very, very important to solve the numericals. So what is the formula here? This is for 2 cross 1 mux. 2 cross 1 mux. This is the formula. Second one for 4 cross 1 mux. This is the 4 cross 1 mux. We are having the 2 selection line. When S1 and S0 both are 0, we are writing S1, S0 bar. It will select I0. When 0, 1, it will select I1. When 1, 0, it will select I2. It will select I2. And it is when 1, 1, both are 1, 1 means S1, S0, it will select I3. And that is the formula for what? Expression for output in case of 4 cross 1 mux. This is the 4 cross 1 mux. 2 selection line is required. 4 input is there here. That is the simple basic idea about the multiplexer. Now, which type of question here? Which type of question here? So, finally, that is the question. So, what is the internal diagram of the multiplexer? Always remember, this is the combination. I am writing already, I have written the output. F, right? S0 bar, S1 bar, S0 bar, I0 plus S1, S0, I1 plus S1, S0 bar, I2 plus S1, S0, I3. So this is nothing but soft form, sum of product form. Here we are getting the sum of product form, first term, second term, third term, fourth term, and we are using one OR gate, and that is the internal diagram of what? Multiplexer. So in the multiplexer already we have all the mean terms, already we have what OR gate, and that's why we can implement any Boolean function by using multiplexer. That is the beauty of multiplexer. So, right, and OR logic, simple. These are and OR logic. This is the AND, this is the OR, 2-level implementation. Ready to solve some questions? Yes, guys, ready to solve some questions? So first of all, that is the question. 1 minute. Yes, tell me, what is the answer for this question? What is the answer for this particular question? We can implement any gate by using what? Multiplexer. We can use any gate by multiplexer. So what is the answer? In the 4 cross 1 multiplexer, the output A exclusive or with B is given by A exclusive or with B is given by this diagram. Okay, na? This is a multiplexer. Find the required input. What is the value of the I3 respectively? Na? I3, I2, I1 and I0. Very simple 1 marks question, direct question. That is in 2015. So it is a simply multiplexer. So we have idea. AB 0, 0, 0, 1, 1, 0, 1, 1. When I am giving as a selection line, so I want output. At this point I want 0. Here 1, here 1, here at a 0. So according to the table, if I am giving the AB as a 0, 0, it will select I0. What should be the output? 0. Connect 0 here. When I am giving the 0, 1, it will select I1. What should be the output? 1. Select 1 here. 1, 0, then 1 here. And 1, 1 means it should be 0 here. Value is 0, 1, 1, 0. That is the value. 0, 1, 1, 0. The answer is what? B. Answer is just B for this particular question. Okay, I think that is clear. Okay, बहुत सारे स्टूडेंट ने B आंसर भी दे दिया, बहुत बढ़िया. तो B exclusive or gate. Then suppose I want to implement the Boolean function 1, 3, 4, 6. Everyone try to understand. 1, 3, 4, 6 using 4 cross 1 mux. It is given 1 for 4 cross AB as a select lines. Let this is the A, this is the B. AB as a select line. Then what will be the question? What is the value of I0, I1, I2 and I3? Tell me in terms of C. In terms of third pin. So we are choosing AB as a selection line. I0, I1, I2, I3 you have to find, and which Boolean function 1, 3, 4, 6 you have to implement. You have to implement 1, 3, 4, 6. Oh, 1 minute. Okay, I have to write that question. Question is 1, 3, 4, 6 by using the multiplexer, and when we are choosing AB as a selection line, what will be the value of the I0, I1, I2 and I3? Then first of all, multiplexer table. Okay. Then here we are writing AB as a selection line, so always write here A bar, B bar, A bar, B, A, B bar and AB. What is this? 0, 0 means what? I0, it will select I0, it will select I1, 0, 1, it will select I2 and it will select what? I3. Now here we are writing C bar and C. Now 0, 0, 0, this number is 0. 0, 1, 0, this number is 2. 1, 0, 0, 4. 1, 1, 0, that number is what? 6. In this way we have to write the number. New students, please watch this. This is actually 0, this is 0, 1. This is actually 0, 0. So A, B, C. So 0, 0, 0 is 0. 0, 1, 0 is 2. 1, 0, 0 is 4. 1, 1, 0 is 6. Now you can write this number 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, that is the 0, 1, 1 is what? 3, 1, 0, 1, 5, 1, 1, 1 is what? 7. Sorry, वो थोड़ा response नहीं कर रहा है, तो please cooperate with me. Okay, that is the number. Okay, now which number is given in the question? 1, 3, 4, 6. 1, 3, 4, 6. Now this is, if there is a one single circle, this will become C, C, C bar, C bar. That is the input. So what is the answer given here? C, C, C bar, C bar. Yes, that is the right answer for this particular question. C, C bar, and that is the answer directly. Okay guys, so that is this is called what? Multiplexer table. So in this way we can find the selection line, write down the proper values here, right, and then make the circle. If circle in both, this also has circle, this also has circle, then only one circle, then this is the C, this is the C bar. If we are not having any circle in this two column, in this value of this this particular column, then it will be 0. That is the value of I0, I1, I2 and I3. Now one important, very very important question on multiplexer. Please try to solve this one. Everyone, 1 minute. Try to solve this question. Yes. We will solve 2 more questions on the multiplexer and you will get the idea about that. Everyone, please try to solve. Give me the answer for this question. Yes, please. 1 minute. Give me 1 minute only. Yes. Now tell me what is the answer. Last one. Okay. For the circuit shown in the following figure, I0 to I3 are the input to the 4x1 multiplexer control bits. The output Z can be represented by. On what is the answer for Z? This type of questions normally in then what is the answer here? Then to solve this question, we will use a different method. What is the method then? First of all, watch this. I3 is what P, I2 is PQ, I1 is what P, I0 is what PQ bar. One method is what? One method, this is the R and S, PQRS. These are the four variable, PQRS. And what is asked here? For the circuit shown in the following figure, I0 and I3 are input, R is the MSB, S are the control. R is the MSB. Means it is the S1, it is the S0. Okay. Right. Then how we are going to write? We can directly write the equation and then with the help of Boolean algebra we can solve, or there are two methods. So I am giving you the different method. First of all, write down the K map like this. K map. Directly. Then this is the case. Okay. Then my dear friends, second case, if what are the selection line? R and S are the selection line. R is the MSB. So write here R bar, S bar, R bar, S, R, S, R, S bar. Okay. Then simple like a K map. But always remember 0, 0 means it will select what? I0. It will select I1. It will select I3. Why I3? Because it is 1, 1. And it will select what? I2. 0, 1. Okay. Here you can write P bar, Q bar, P bar, Q, PQ, PQ bar. Okay. Simple. Just like a K map. Now, first of all, if what is I0? I0 is P plus Q bar. P plus Q bar is the I0. Q0 is the I0. So when I am selecting the I0, this is the P plus Q. Means where is the P is 1? So P is 1 here, P is 1 here. So you can directly write 1, 1 here. And where is the Q bar? Q bar is here. Or Q bar is here, Q bar is here. So you have to consider Q bar only. So these are the numbers. This is for I0. Directly you can write. Directly you can write like this. This because it is I0. Now second one, what is the I1? I1 is P. So I1 is P. So this is the I1. P means where is the P is 1? Here 2. P is 1, 1. For this 2 it is 1. Then what is the I2? I2 is PQ. PQ, I2. PQ means that is the one. Which one is the I2? This one is the I2. So this is the PQ only. This block represent PQ. So it is 1 for I2. Then finally, what is the I3? I3 is what? P. So again I3 is P. P means this one, this one. This is the one. Okay. Now, very simple. You will get this numbers 1, 1, 1, 1 and so on. Once you will get, simply remember, now we can solve Boolean algebra by using this. So what is the answer here? Remember, answer is of what? 2 variables. It is of 3 variables. It is of 3 variables. 2 variables, 3 variables, 3 variables, 3 variables, 3 variables, 4 variables. Means only one term have the 2 variables. So when we are making the group of 4, quad, group of 4, then you are going to get the 2 variables. Or when we are making the pair, you are going to get the 3 variables. Okay. So how we can solve this? First of all, which term is there? PQ, PQ bar. Is it possible to get the PQ? PQ. Right. So when I am making the pair of this, simply you have to remove this number, okay, P and Q. So tell me which one is possible here, right? Yes, everyone, tell me. When I am making the group of these two, what is removed here? When I am making the group of these two, what is removed here? R bar, S bar is removed here, and you can say, so check the numbers again, you can check this number, okay. R, S bar, S is removed here, so it will become what? P, Q, R bar. सॉरी, थोड़ी सी बोर्ड पे प्रॉब्लम है, राइट। I3 का मैप, ओके, I3 के मैप में थोड़ी सी प्रॉब्लम हो गई ना, ये थोड़ा सा बोर्ड थोड़ा सा कोऑपरेट नहीं कर रहा है। 1 मिनट रुकिए, 1 मिनट, हमने तो I3 की एंट्री ही नहीं की है यहाँ। वी आर नॉट गिवन द एंट्री ऑफ द I3 हियर, सॉरी फॉर दैट। यस, दिस वन, राइट। फॉर दिस पर्टिकुलर क्वेश्चन ऑलरेडी आई हैव गिवन यू द हिंट फॉर दिस वन। देन okay, first of all, try to understand, when we are making the K map, remember what is the I naught? I naught is equal to what? P plus Q bar. Okay, what is the I1? I1 is given as P. What is the I2? I2 is given as what? PQ. And what is the I3? I3 is given as what? P. Now, if you want to solve this question, very simple. First of all, make a proper K map, right? What are the selection lines? Selection lines are what? R and S, MSB. This is MSB and this is what? LSB. Then already I have given you the hint, draw the proper K map. After getting the entry, right, for I0, I1, I2 and I3, then make proper pairing, just like what, how to minimize the Boolean algebra by using K map, and finally you will get the answer. But remember, when we are watching the answer, here only 2 variables are available, means we have to make the pair of what? 4. Here 3 variables are available, means we have to make the pair of 3. Here 3 variables are available, we have to make the pair of 2, this 2. Here we have to make the quad, here pair, here it is a pair. Again quad, pair, 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 single one, single, pair, pair, single, single, pair. So according to this, you have to check the answer. According to the given answer, we have to verify the result. Okay guys, so that is the hint. Tomorrow I will solve all this question. Okay, so because 4 p.m. again you have class, 1 hour break is required. Please solve by direct marks. Directly, you can directly write it like this: R bar S bar into I naught bar, I naught, R bar S into I1, R S into I2, and so on. Directly you can write this equation like this. That is what is the output of Z. R bar S bar I naught. What is the I naught? P plus Q bar plus. But I am giving you the very easy method. R bar S I1. What is the I1? P plus R S bar I2, PQ plus R S P. Right? With the help of Boolean algebra, again you can find the answer. With the help of Boolean algebra, you can find the answer. But with the K map, again you will find the answer within seconds. Okay. So that is the method. Right? So thank you for attending the session. Now I am giving you the information about the next class. We will solve more question on multiplexer. These all are the questions on multiplexer, and I will give you the idea how to find the delay, maximum propagation delay in case of what? Multiplexer. So everyone, please try to solve this question. This is a homework for you. In 2016, one question on delay that is related to multiplexer. Again, similar type of question in GATE 2021, and that's why we have to solve what? Previous year questions. try to solve the previous year question. So this is another one. Then again in 2015, very important question from the multiplexer. Tomorrow we will solve this question. Okay. So this is all about the digital, but remember one thing, GATE and DSE test series get unlimited access to full length mock subject test. Link is given in the description box. Just after this session, you can go through that link and join this test series, right? Then why 60 plus test covering GATE and DSE, detailed mock analysis, virtual scientific calculator is available, curated by the GATE experts. You are going to give the all India open mock, and 4,000 plus practice questions are also available. So you can join this test series, and that is the time for test series. You are on BYJU'S exam prep. Thank you for attending the session. Thank you very much. Subscribe the channel. Okay. Like the session and share the link of this session and join network sharp at 4 p.m. We are waiting for you 4 to 8 p.m. Circuit theory, complete revision of the circuit theory or network. Thank you and good day. Okay guys, thank you. Code for that is logic, L-O-G-I-C. Remember that code for PDF. The code is logic, L-O-G-I-C. So note this code, okay guys, everyone. Okay then, thank you.